we can start this one, geotechnical engineering. So this is our topic. Okay. அப்புறம் நமக்கு வந்து டிஎன்பிசி ஏஇல வந்து செக் பண்ணும்போது நமக்கு வந்து ஜியோடெக்னிக்கல் இன்ஜினியரிங்ல எவ்வளோ கொஸ்டின்ஸ், நம்பர் ஆஃப் கொஸ்டின்ஸ் தே ஆர் ஆஸ்கிங் இஸ் ஆக்சுவலி லாஸ்ட் இயர்ல 2022 வந்து செக் பண்ணும்போது இட்ஸ் அரௌண்ட் 18 கொஸ்டின் தான். தே ஆர் ஆஸ்கிங் 18 நம்பர் ஆஃப் கொஸ்டின்ஸ். ஓகே. And even 2019, 2018 ആ ഒരു സിനാരിയോ എല്ലാം ചെക്ക് பண்ணி பார்க்கும்போது geotechnical engineering பொறுத்த வரைக்கும் they are asking about 20 range. Okay, 22 number of questions. So that is very important because out of 200 10% is asking from the geotechnical engineering, around 10%. Okay. So before starting to the topics, I just give some overall idea about how much how many topics they are asking and how much the distribution of the topics are. Okay, so that is very important before starting any topic or any subject. Okay, so geotechnical engineering general classify panana, that is soil mechanics is one branch, and second branch simply we can see that is foundation engineering. These are the two branches. Okay, GT, geotechnical engineering check பண்ணும்போது you can see these two hands. Okay, two branches, that is soil mechanics and the foundation engineering. So general check பண்ணும்போது you can see last year 2022 வந்து geotech வந்து ஒரு நிமிஷம் 2022 வந்து டாபிக் என்னென்ன டாபிக் அவங்க கொஸ்டின் வந்துட்டு செக் பண்ணி பார்க்கும்போது ஃபர்ஸ்ட் வந்து டாபிக் வைஸ் செக் பண்ணும்போது ஃபர்ஸ்ட் கொஸ்டின் இப்போ அந்த தான் பேச போறேன். So one is soil exploration, that is one of the topic they are asked, soil exploration. அதுன்னு வந்து 3 questions தான் வந்துட்டாரு. Okay, second வந்து compaction, that is one of the another important area, அதுல வந்து 2 questions they are asked. Okay, third வந்து shear strength. Okay, shear strength, then stress distribution, seepage analysis, index properties, soil classification, pile foundation, bearing capacity, stability of slopes, effective stress. See, நீங்க வந்து syllabus check பண்ணும்போது almost 90% area they are covered. Okay, why I wrote these 3 things, because these are mainly asking even index properties. They are also very interested to ask questions from index properties, that you will see. Even last year, last 2022 வந்து 4 questions that they are asked. Okay, shear strength வந்து 2 questions. Okay, so these are the main areas they are focused in last year. Even in 2019 also these kind of index properties, 2019 when the index properties on the 4 questions they are asked, and when the soil exploration when the check பண்ணும்போது 2 questions they are asked. Okay, so நம்ம பொறுத்த வரைக்கும் soil mechanics and foundation engineering, these two are very important. Okay, these two are very important. Foundation engineering just அது எப்படி division வந்ததுன்னா pile foundation, bearing capacity, അല്ലെങ്കിൽ shallow foundation, pile foundation, இதுதான் foundation engineering மெயினா வருவாங்க. ஓகே, foundation engineering வந்து shallow and deep or pile, shallow and pile. So generally check பண்ணும்போது last year 2022 வந்து check பண்ணும்போது bearing capacity, that means shallow foundation 1 question they are asked, and pile foundation 1 question they are asked. So 2 question, or okay, 2 question. 2019 check பண்ணும்போது shallow foundation 3 questions they are asked, pile foundation 2 questions. 2018 check பண்ணும்போது pile foundation 1 question and shallow foundation they are asked 4 questions. So in and around I am going to classify like this. This is around 5 to 6 questions they are asking in shallow and pile foundation. Okay, remaining around 14 to 15 questions they are completely coming from the soil mechanics portion. Soil mechanics பொறுத்த வரைக்கும் those questions are coming from mainly from index properties. Okay, and consolidation, that is coming, then soil classification, seepage analysis. Okay, these are questions coming from the soil mechanics. Foundation, I am just classifying this only, and again more topics are there, soil exploration, these are coming from the foundation topics only, foundation under foundation only, but I'm just focusing foundation. As the name indicates, it is shallow foundation, pile foundation. This is coming, and 5 to 6 questions are coming generally. Okay, now we will see the scenario. First one, these are the some idea that you have to focus about the geotechnical engineering. So this is very simple subject actually. It's very easy to understand and easy to crack the question. First of all, இது வந்து நீங்க எப்படி படிக்கணும்னா இட்ஸ் வெரி சிம்பிள் டு அண்டர்ஸ்டாண்ட். ஃபர்ஸ்ட் திங், கான்செப்ட்ஸ் வந்து அவ்வளோ சிம்பிளா இருக்கும். ஓகே, வெரி வெரி சிம்பிள். அண்ட் தே ஆஸ்க் 2 or 3 ப்ராப்ளம்ஸ் ஃப்ரம் த சம் டாபிக்ஸ், ஃப்ரம் த சம் டாபிக்ஸ். மெயின்லி லாஸ்ட் இயர்ல வந்து ப்ராப்ளம்ஸ் வந்து ஃபைல் ஃபவுண்டேஷன்ல வந்து ப்ராப்ளம் தான். bearing capacity, that is shallow foundation வந்து சின்ன ப்ராப்ளம்ஸ். அகைன் சாயில் எக்ஸ்ப்ளோஷன் வந்து ப்ராப்ளம்ஸ் வச்சு. அப்போ 3 ப்ராப்ளம்ஸ் இன் 2022 and again 3 problems in 2019. 2018 again 3 problems. So you can expect 3 problems, simple problems, and remain 15 to 18 questions, 16 questions maybe theoretical only. This is the expectation for 2023, that is 24 exam. Okay, so minimum 3 problems they will ask. So problems பொறுத்த வரைக்கும், again I am saying no need of calculator, simple hand calculation is needed actually. Okay, so first வந்து இப்போ டாபிக் லைக் நமக்கு வந்து ஜஸ்ட் செக் பண்ண போலாம். அதில் வந்து நீங்க சிலபஸ் செக் பண்ணும்போது அதுல சாயில் ஒரிஜின் ஆஃப் சாயில் கிளாசிஃபிகேஷன் அந்த மாதிரி இனிஷியல் டாபிக்ஸ் யூ கேன் சி, பட் நோ கொஸ்டின் ஹாஸ் சின்ஸ் லாஸ்ட் 5 or 6 years. Okay, so that is not needed actually. You can just brush through into that topics. Actually it is very simple. Origin of soil is nothing but how the soil is originated and the classification and different soils in India. Okay, so that things we will study in the last area. Okay, the last classes. Initially why I am focusing the important topics was actually the definition. I mean whatever questions they are asked in the previous exams, no, that area we have to focus. Okay, so major areas that we will cover today is mainly soil properties. These are the initial stages. Okay, initial stage of geotechnical engineering. Mainly soils properties வந்து we will study some definitions and some experiments. Okay, second we will study about index properties. This is one of the important area you can definitely expect question from this. Just note பண்ணுங்க, in the year 2024 January 6 or 7 நீங்க எக்ஸாம் எழுதும் போது index properties, whatever things we are going to study, you will get 2 or 3 questions from that. This is 100% sure. Third one, the soil classification. This is also very important. Soil classification. Maximum we will cover these 3 topics. Okay, if time permits we will move to permeability also. Okay, at least we have to cover these 3 areas. So one by one we will check what are the soil properties, what are the index properties, what are the soil classification, how can we classify the soil. Okay, so this is the general idea that I have to share with you, because before starting to any exam or any subject, okay, you have to get an idea. You should have maximum idea about the topics, what you need to study, what you don't need to study. That is the idea. Okay, not need study and need not to be studied, because area wise, topic wise, this is a very large subject. Okay, and we have only 2 months of preparation. Okay, so we need to prepare it in a smart way. That is what I am going to serve you in a smart way of study. Okay, so this is it, just information, just a basic information for you. Now we are going to pick the main area. Okay, first one I am going to focus on definitions, and again in that we will see 3 phase diagrams. Okay, so that area are coming in the syllabus. Okay, so one by one we will start. So I hope you get an idea about these things. Vinita, Sinju, Kamala, Indira. Okay, so we will start one by one. These are some basic idea that I give in order to understand these things. Okay, so first I will start with soil. Okay, I will start with the soil. So geotechnical engineering, why we have to study geotechnical engineering? That is my prime area. Why I need to study? Because in order to construct a structure, anyway, we are going to construct it in above the soil. Okay, soil the ellame building ആയിക്കോട്ടോ ടവർ ആയിക്കോട്ടെ എല്ലാമേ வந்து soil above the நம்ம construct பண்ண போறேன். The whole load coming from the structure is transferred to soil itself. Okay, that is the idea. So in order to make the stability of the structure, இந்த structure வந்து இப்படியே ஒரு 50 years அப்படியே நிக்கணும்னா we have to check whether the soil can carry this load, whatever load coming from the structure, that load should be carried by this soil for 50 years at least. Okay, soil எப்படி இது carry பண்ணணும்? So soil should have enough strength. Okay, so அந்த strength எப்படி soil கிடைச்சு? Okay, soil எப்படி அந்த strength build பண்ணிட்டு அவ்வளவு லோடு தான் வருது. ஸ்ட்ரக்சர்னா சம்டைம்ஸ் 900 டன் 1000 டன் அந்த மாதிரி லோடு தான் வருது. அந்த லோடு எப்படி இது soil வந்து கேரி பண்ணணும், எப்படி அந்த ப்ராப்பர்ட்டிஸ் அது soil கிடைச்சு, அந்த soil அந்த ப்ராப்பர்ட்டிஸ் அதெல்லாமே தான் நாம செக் பண்ண போறேன். அந்த ப்ராப்பர்ட்டிஸ் அது வந்து ஜெனரலா சொல்லுவாரு, அது வந்து engineering properties of the soil. Okay, this is very important. So in order to understand the engineering properties of the soil, we have to understand, we should focus on the basic properties, basic definition of the soil, basic definition, basic properties, basic components. So in soil பொறுத்த வரைக்கும் what are the components or what are the constituents in it? First you have to address that one. What are the constituents? What are the constituents of a soil? So I am going to collect a soil from the ground. When I am focusing on the soil particles, okay, when I am focusing on the soil particles, you can see these soil particles in it. Okay, these are the soil particles, and you can see some gap between the soil particles. Definitely there will be some gap. So that gap is actually called voids or void spaces. Okay, the black shaded one is actually what is solid particles or soil particles. Okay, so in soil you can see soil particles or solid particles. The space between the solid particles actually it is called void spaces. In the void spaces, when you are checking in the void spaces, simply you can see some amount of water in it. Maybe it is available, may not be sometimes. So water irukkalam, sometimes air kuda irukkalam. Okay, so water plus air plus solid particles, this is a soil. So suppose you collected this soil from a river bed. Okay, or a river, this is a river and this is a river bed. So you collected the soil from the river bed. So what you can expect from the soil, when you check the soil, the soil வந்து soil particles, the space between soil particles வந்து complete of water fill பண்ணிடும். So the constituents of a soil from the river bed, actually two components will be there, solid particles plus water. So by knowing these things, I am just classify that, or I am just giving some name to the soil. Okay, different conditions of the soil. First one is actually fully saturated soil. What I am saying, a soil which is collected from a river bed is actually, it's called fully saturated soil. Why I just called fully saturated soil? The saturated word is actually belongs to water. What? Okay, in the geotechnical engineering பொறுத்த வரைக்கும் saturated word வந்து எப்பவுமே water related தான். It's equal to water னு சொல்லுவார். So fully saturated, that means fully water in the void. So அந்த constituents யாரெல்லாம் செக் பண்ணும்போது அங்க solid particles plus water, it is there. Second வந்து check பண்ணா அது வந்து partially saturated soil. Partially saturated soil. So as the name indicates, you can see the difference from fully saturated and partially saturated. Actually, partially saturated soil, it is solid particles is there plus water is there. So whatever amount of void spaces in a partially saturated soil, some spaces are occupied with the water and some spaces are occupied with the air. So simply I can say solid particles plus water plus air, that is a partially saturated soil. A fully dry soil. Third one is actually a fully dry soil. How you can classify that? I mean, how you can differentiate that one? Because for a fully dry soil, as the name indicates, it is actually solid particles will be there, solid particles plus what is the other component? Whatever amount of void spaces in there, it is fully filled with air. So air is occupied in the void spaces because it is a fully dry soil, no water is present. So this is a major classification or major names that is given to the soil based on whatever amount of water or air present in the void spaces. If it is fully saturated, the full void space is filled with water. If it is partially saturated, the void space is filled with water and air. If it is fully dry soil, the whole void space is filled with air only. So this is the basic idea. This should be noted because from this I am going to derive or I am going to create the phase diagram. Okay, so phase diagram. So next area on the phase diagram. This you can note down because parallel you can note down. Okay, basic. These are the basic things. Okay, these are the simple things also. So you have to parallel write the things in your note, and whatever things going to be important for your exams, that I will give, that I will share as a note. That means I will tell you in order to write. Okay, so these are the simple way. So you can roughly note down this one: fully saturated, partially saturated, fully dry soil. Okay, so next one, I am going to create a phase diagram. So what is phase diagram? Without phase diagram we cannot identify or we cannot tell about the properties or definitions of a soil. Okay, so phase diagram is nothing but it is a simple way of study. That's all. What for study? What study soil? Okay, the study soil one, we know there are solid particles. Okay, there are solid particles and there are water and air also. So we should know how much amount of water is there or how much amount of solid particles is there. So how much weight is there? That kind of idea we need to know. Okay, why we need to know about the idea? I mean, how much quantity or how much weight? Because see, as earlier I said, there is one engineering property, right? One word, engineering property. So what is the engineering property that you will see? So the engineering property actually given to the soil by interaction. Simply I can say the interaction of the soil constituents or soil components. So what are the soil components? Water, air, solid particles. Okay. So the engineering property actually given by the soil particles or soil components, how they are going to give, they interact with each other and they impart this property. So that's why we are mainly focused on how much quantity, எவ்வளவு quantity இருக்கு, so volume, எவ்வளவு volume இருக்கு, எவ்வளவு weight, அந்த மாதிரி terms எல்லாமே நமக்கு வேணும். அதுக்காக தான் அது simplify பண்ணதுக்கு. Okay, in order to make it very simple, we are creating this phase diagram. So phase diagram என்ன பண்ணுவோம்னா simply we will differentiate. Okay, differentiate these things, these three components. Okay, just see. Now I am going to draw a phase diagram for a partially saturated soil. So a partially saturated soil, you know the condition. What are the components in the partially saturated soil? We can interact with each other. Okay, so Kamala, what are the components of a partially saturated soil? You can unmute and you can interact with me. Kamala. Meanwhile, I will draw the diagram. So I need that time. We can use the for it to interaction. Okay, Kamala, are you there or can you hear? Vinida, are you there? No one is there. Sinju, anyone, please?
Hi, sir. This is Vinod. Sir, for partially saturated water plus air plus soil, sir.
Yeah. Okay. So for a partially saturated soil, water, solid, and air is there. So now I am going to create the diagram, phase diagram. How I can create the phase diagram? So someone is texted me. I want to check. Yeah, water, air, soil. Okay. Very good. Yeah. What is the disturbance? I didn't even with my mic or hello.
Yes, sir. Audible, sir.
Audible தானே? ஏதாவது disturbance இருக்கா? Like,
No, sir. No, sir.
okay, fine, thank you. Okay, so let's continue. So phase diagram வந்து எதுக்காக? Because we have to know about the quantities, the volume, weight and all. So for a partially saturated soil, I am going to draw this one, partially saturated soil. We know okay. So okay, Kamala. Don't worry. Okay. So partially saturated soil வந்து யாரெல்லாம் இருக்கு? We know solid particles, okay, water and air. So I am going to draw the phase diagram for this one. What I am going to do is I just collected all the solid particles, whatever solid particles here, I just collected and I just fill here. Okay, complete packed inga fill punish. Okay, so this is solid particles in my soil. Now I am going to fill in the second area whatever amount of water is there in the solid particles. I just filled here. Okay, I just filled here. This is water. Now I just collected all the air from the soil and I just filled in the third phase and it is completely air. Simply I created a phase diagram. Okay, this is a phase diagram. So phase diagram பொறுத்த வரைக்கும் you have to segregate or you have to differentiate the components and you have to fill in each phase. That's why it's called a phase diagram. Why we have to fill in the phases? In order to identify the volume or weight. Okay, now I am going to share you the idea about the phase diagram in more detailed way. So phase diagram is actually a diagram which shows the components of the soil, and you can create 3-phase diagram, 2-phase diagram, okay, even 4-phase diagram also there. So we are only focusing on 3 and 2-phase diagram. So this is a 3-phase diagram because there are 3 phases: solid phases, water and air. Okay, so these are the 3-phase diagram where for partially saturated soil we can create a 3-phase diagram. For a fully saturated soil you will get only a 2-phase diagram because only 2 component. Okay, for a fully dry soil you will only get a 2-phase diagram because only there is 2 components. Which are the components here? Fully saturated solid particles plus water. Here it is solid particles plus air. Okay, so while you are going to create a phase diagram for a fully saturated soil, you will get a phase diagram like this. Okay, like this, and here it is solid and here it is water. Now you are going to make a phase diagram for a fully dry soil. You will get a solid particle in the first phase, the second phase you will only air. So this is the idea. Okay, so 2-phase diagram and 3-phase diagram are there. Now what is the use of this one? Okay, so I am going to draw some informations in this diagram. Just check it out. So these arrows shows I am going to draw like this. I am going to write like this: Vs, that is volume of the solids, volume of the water and volume of the air. Okay, so in the left hand side of the 3-phase diagram I just given the values of volume of solid particles, volume of water and volume of air. It's an indication. Okay, now I am going to draw another arrow which shows the complete volume of air and water. So volume of air plus volume of water, you can simply say volume of air plus volume of water, it is nothing but volume of void. That is simple because whatever amount of void is there, it is completely filled with air and water. Whatever amount of void is there, it is filled with air and water. So volume of air plus volume of water is nothing but volume of void. Now I am going to mark another volume, that is nothing but the total volume. So total volume is, it's nothing but volume of the void plus volume of the solid. Okay, volume of the void plus volume of the solid. This is the total volume of the soil. So for you people, whenever you had a volume of the soil, okay, the volume of the soil and the weight கேட்கும்போது what you have to understand is in that there will be solid particles and the space will be there. So volume of solid and volume of the void, that two terms should be come into your mind. So in the volume of the void, okay, in the volume of the void, யாரெல்லாம் இருக்கு அங்க வந்து air, volume of air plus volume of water plus volume of solids, that is total volume. This is the idea. See, total volume means volume of the solid particles plus volume of the water plus volume of the air. This is very basic things because these things should know because sorry, by analyzing or by knowing this volume, you need to focus on the properties or definitions. Without knowing these volumes, you cannot define the properties or basic definitions. Okay, that is the idea. In the right hand side, I can simply draw the weight of the solid. Here it is weight of the water. Okay, weight of the air, it is not needed. So the total weight is weight of the soil. So the weight of the soil is nothing but weight of the solid particles plus weight of the water. Weight of the air is there, but it is negligible. Okay, you can take it as 0. So this is the idea. So normally in the right hand side of the phase diagram, we will show the weight, and the left hand side we will show the volume. Okay, so this is the basic things, and இது நீங்க important இந்த ஐடியா உங்களுக்கு கட்டணும், இல்லைன்னா we cannot define the basic definitions. Okay, so we will move to the basic definitions. So I hope you wrote these things and you draw these things, because again I am saying you have to draw this one and you have to show this weight and volume in the left and right accordingly. Okay, so next one, we will move to the definitions. This is the important thing for a exam point of view. From here you have to start. Okay, from here you have to start. Basic definitions one. I'm going to classify the definitions in the two way. Volumetric definitions. Volumetric definitions. That means volume based definitions. Definitions is nothing but properties. Okay, basic properties. Second one the weight based definitions. These things are very, very basic, and it carries a major role in the upcoming topics. Keep it in mind. Okay, very important. You have to study, or you have to mug up this one. Don't need to, I am suggesting no need to mug up these things. You have to understand these things. Okay, first one, volumetric definitions or volume based definitions, we have to focus on void ratio. Second one is porosity. Third one is degree of saturation. Fourth one is air content. Fifth one is percentage air voids. Okay, so 5 major definitions, very, very important for you. Void ratio is notated by E, porosity is N, degree of saturation is S suffix R, air content you can show like A suffix C, percentage air voids again N suffix A. This is the major notations. Okay, void ratio, porosity, degree of saturation, air content. In weight based, we will see water content, and second one is mainly unit weight. Even in unit weight, there are a lot of different types of unit weights are there that you will see. Specific gravity is also a term associated with the weight. Specific gravity. These 3 important terms you have to study. But in unit weight, there are different unit weights are coming. So that you will see one by one. So first one is actually called void ratio. See, no need to write this table because one by one we will see. Okay, so that's why I just move to next slide. So void ratio, that you will see. 1 minute. Yeah, void ratio. See, in 2019, one question was asked based on these definitions. One problem. Okay, that we will see. Actually, by knowing the void ratio, porosity, degree of saturation, and this water content and unit weights, at least you should know about the basic definitions. Okay, uh, at least you should focus on the equation itself. At least, what I'm saying, at least. Okay, but in my point of view, you should understand the concepts also. So exam பொறுத்த வரைக்கும் இந்த வந்து problems, they are asking problems, it is very easy to crack the problems by knowing the equations. Okay, simply you can mug up the equations and all, but if they are asking some concept based questions, it will trouble you. So you have to understand the concepts also. See, first one by one we will see the concepts. First one is void ratio. So void ratio is nothing but that things you know. So who is going to recollect that memory from your brain? Vinita, are you there? What is void ratio? Yeah, volume of voids by total volume. Actually, absolutely it is wrong. Sorry Vinita. See, this is a problem. If you're going to mug up these things, definitely it will come the output like this, because whatever Vinita said is actually the volume of Vinita's response is actually volume of the voids by total volume. Okay, anyway, I'm going to define the void ratio as, see, volume of voids to volume of solids. Okay, so I'm going to produce the three-phase diagram in front of you. See, this is a three-phase diagram. Okay, just a rough diagram. So we know this is solid particles, this is water, this is air, and representation of this much is volume of solid, this is volume of water, and this is volume of air. Okay, sufficient. So, and this total volume is volume of void. Now check this one. Void ratio is the ratio of the volume of voids to volume of solids. Okay, volume of voids to volume of solids. It's not volume of voids to total volume. Volume of voids to total volume is the another term, porosity. Okay, so don't confuse these things, because this is, again, I am saying very basic things. Okay, void ratio is volume of the voids to volume of the solids. Now see the magic. Void ratio, this is an engineering term. Mainly a geotechnical engineer should focus on here. Geotechnical engineering term tha, because we are going to compare this with the void porosity. Okay, so both of the terms we will study simultaneously. Porosity, now you will find the difference. Porosity is absolutely a agricultural engineering term. Agricultural engineer term. Okay, so we know we are studying only geotechnical engineering. We don't need to focus on the agriculture engineering area. Okay, so for us, geotechnical engineer, the prime focus is on void ratio only. As a prime focus, இது வந்து void ratio வந்து, this is very important for you. But why it is very important? Because in the denominator it is volume of the solids. Okay, now porosity, again I am going to simultaneously define the porosity also. Porosity is defined as volume of the void to total volume into 100% நமக்கு சொல்லலாம். So porosity is actually the ratio of volume of voids to total volume, and void ratio is the ratio of volume of voids to volume of solids. This is the very important difference between porosity and void ratio. Okay, but porosity and void ratio, they are siblings, but they have different properties. Okay, different idea. They are siblings only. அப்ப படிக்கும்போது நீங்க first void ratio, then porosity, அந்த மாதிரி கிளப் பண்ணி you just focus, study that one. Okay, கிளப் பண்ணி படிக்கும்போது அது கொஞ்சம் கூட ஈஸியா இருக்கும். So void ratio is nothing but volume of voids to volume of solids. Again, it is a geotechnical engineer பொறுத்த வரைக்கும் that is very important. Why it is very important? Because the denominator is actually a constant for a soil. Volume of solids, just see, whatever amount of solid particles in a soil, if you are going to, suppose this is a condition of the soil here, if you are going to compress the soil or compact the soil, so whatever amount of soil particles included in the soil element, it is again remain as it is same in the compacted form itself. What is the change in this compaction? You are giving some tampering into the soil and the compaction is happening. Okay, compaction is happening. What is the change? The volume get reduced. How the volume get reduced? The void spaces get reduced. The void spaces get reduced. How it is get reduced? The air in the void spaces escaped. Okay, air வந்து இங்க இருந்து the tamper பண்ணும்போது just you are giving some forces here, air escape ஆயிடுச்சு, அப்புறம் volume reduced ஆயிடுச்சு. அப்ப என்ன volume, எந்த volume reduced ஆயிடுச்சு? அது volume of void spaces தான் reduced ஆயிடுச்சு. ஆனா volume of solids அப்படியே சேமா இருக்கு. So that is why I am saying void ratio, it is very important term. Why? Because we can compare the soil in different conditions using the value of E. Okay, so here E value, here E value, if you compare this condition, E value will be more in this comparing with this condition, because here volume of the voids is get reduced. See, volume of the void get reduced, but volume of the solid is same as it is, because this is the same soil. We didn't pick any solid particles from here, or we didn't add any solid particles to here. Got my point? Solid particles we didn't include, or we didn't remove any solid particles from the soil. What we did, we just applied some forces on the soil particle, I mean the soil, and through that forces the air in the soil is just escape, and the void spaces get reduced, thus the volume get reduced. Okay, so here volume of the solids is same as here. Volume of the solids is same. That is very, very important term. The situation, volume of the solids in both conditions are same, but volume of the voids, it is not same. So E is greater than, okay, this is E uncompacted, this is compacted. So suppose if you are getting a value of 1.7 here, this is 1.2. Okay, so by knowing the void ratio, you can simply say the void spaces in the first condition is more than the second condition. You will get an idea, right? So thus the void ratio is very, very important for us, for a geotechnical engineer. But the porosity is actually for agriculture. See, porosity, the word itself same, how much porous the soil is, how much porous, எவ்வளோ pores அங்க இருக்கு. Okay, how much porous, that is porosity. So how much porous? Suppose you are considering a sponge. Okay, sponge consider பண்ணும்போது the whole volume, how much the sponge, how much porous was the sponge? Okay, அப்படி ஒரு question உங்ககிட்ட வரும்போது what you will see, the whole volume of sponge எவ்வளோ pores இருக்கு, அதுதான் உங்க ஐடியா. You will say this much amount of pores is there in the total volume. Likely you can simply say how much porous the soil is, how much porous the soil is. That means porous indication is actually void. Porous means how much void is there. So you have to consider the volume of void. Why we have to consider the volume? Because we are studying only volumetric definitions. Okay, volumetric definitions. Okay, see, these are all volumetric definitions. That's why we are taking volume only. Okay, are you getting my point or not? So porosity is volume of voids to total volume. Total volume எவ்வளோ porous இருக்கு, எவ்வளோ void space இருக்கு, that is porosity. Volume of solids, that is a constant term for a soil. Volume of solids பொறுத்த வரைக்கும் எவ்வளோ void spaces இருக்கு, அதுதான் void ratio. These are two terms, different terms, but siblings தான். Okay, அவங்க siblings தான், ஆனா properties அவங்க properties வந்து different, behavior வந்து different இருக்கு. So this is for engineering, geotechnical engineer, this is for agriculture. Because agriculture பொறுத்த வரைக்கும் agriculture engineering வரும்போது எவ்வளோ porous இருக்கா, suppose soil அது வந்து எவ்வளோ quantity of water hold பண்ணிட்டு இருக்கு, அதுதான் அங்க plant grow பண்ணுமா இல்லையான்னு determine பண்ணுவாங்க. Okay, so that we have to know how much porous it is. So this is the two terms you have to focus on. Now I am going to define the limit of void ratio. So void ratio should be greater than 0. This is the idea. Void ratio cannot be equal to 0. If anyone is writing like this is absolutely wrong. E cannot be equal to 0. Why? Because See, volume E should be E. Suppose E is 0, that means volume of the void is 0. Volume of the void is 0. That is not possible for a soil. Okay, that is not possible for a soil. For any soil, the void spaces will be there. You cannot create a soil without any space or void spaces. So any soil having void spaces. So volume or void spaces will be there. Anyway, volume of solid spaces, it won't be 0. That means E should be greater than 0. E should be greater than 0. E should be greater than 0 means what is the upper limit? Lower limit, I got an idea. E should be greater than 0. What is the upper limit? There is no upper limit for the value of E. Why no upper value? Because see, in this condition, suppose this is 33%, this is 33, and this is 33. So I just divided into 1/3. Okay. So 33, approximately 33%. So what our weight? Volume is 33 mm cube. Here it is 33 mm cube. Here it is 33 mm cube. So now I am going to find out the E value. E value is volume of voids, that is 66 mm cube, divided by volume of solids, that is 33. Here it is 2. Okay. Here volume of voids is very, very high compared to volume of solids. Again, it can be 3, it can be 4, it can be 5. Okay, it can be achieve any value. So that's why it is called E is greater than 0. The limit or the condition for value of E should be greater than 0. This is very, very, very important because they can ask statements. They can ask statements from this concept. Okay. So what you need to understand is whenever a question is asked based on E value, void ratio, suppose the limit or the equation, you just focus on the what? Phase diagram, 3-phase diagram. From that one, first you have to stick on what is a void ratio. First thing, it is a geotechnical engineering term. Why it is a geotechnical engineering term? Using the void ratio, I can compare the soil, different condition soils. So that means the denominator, in order to compare with the values, the denominator should be constant. So that is volume of the solids. Okay. And above it is volume of the voids. So volume of the voids to volume of the solids, that is a important term. It is void ratio. Porosity, that is agriculture term. So again, porosity is volume of the voids to total volume. How much porous? The porosity, whenever a porosity term coming to your mind, the statement should be coming to your mind is how much porous the soil is. That means the total volume of voids to total volume of the soil into 100. Percentage the normal நம்ம porosity denote பண்ணுவாரு. Okay. So porosity அது வந்து எவ்வளோ range, okay, எப்படி limit எப்படி set பண்ணுவோம் check பண்ணலாம். That is another next point. So porosity, what is the upper limit and what is the lower limit? Anyone? What is the upper limit and what is the lower limit? Now, Indira, just tell me what is the upper limit of the porosity, or second one is what is the lower limit of the porosity? Just tell me. Quick. First upper limit, Indira, or if Indira is not there, Kamala. What is
upper limit is 100, sir.
Upper limit is 100. So you are saying upper limit is 100. N value equal to 100%. So lower limit?
Maybe 0, sir.
You are saying N is 0. So I am going to write like this: 0 less than or equal to N less than or equal to 100%. Okay, as per you, whatever you said, actually it is wrong. Why it is wrong, we will see. Just check it out. Porosity, 100%. Can it be 100%? What is the definition of the porosity? Porosity is actually nothing but the volume of voids to total volume. So if N is 100% or 1, that means volume of the voids is equal to total volume. Adengappa. Volume of the voids is equal to total volume. Is it possible?
No, sir.
No, because volume of the voids total volume equal anga volume of solid, that is solid particles illa, that is not a soil. So you cannot say N equal to 100%. You can only say N should be less than 100%. Are you getting my point?
Yes, sir.
Yes. So How we know that one? Because volume of the voids cannot be equal to the total volume of the soil. That is a solid fact, right? Because if there is volume of the void equal to volume of the soil, you cannot say it is a soil. You cannot say it is a soil. Now the lower limit. What is it when n is equal to 0? That means volume of the void is equal to 0. That is again not possible. We already told, no? E cannot be equal to 0. Why E cannot be equal to 0? Because volume of the void equal to 0. That is if not occurring. It is not occurring because all the soil in the earth is having void spaces. So volume of the void cannot be equal to 0. Again, I can say n cannot be equal to 0. Okay, n should be greater than 0. The range is actually here equal to, and the equal sign you can remove. So I can simply write, I am going to simply write it is 0 less than n less than 100. It is very important. Again, I am expecting question from this kind of area because they will say like pick the wrong statement from the following statement. They will say, they will given like this. The A option will be the void ratio cannot be equal to 0. Okay, fine. The maximum limit of the porosity is 100%. Absolutely wrong. So likewise, the questions will ask. Okay, so keep it in mind. The range value of the porosity and void ratio. Okay, so it is very important. So whatever things you have to note is the E value. E value is volume of the voids to volume of the solid. The range. What is the range of the E value? That is again important. And second one is porosity. Again, it is what is porosity. You can simply write in terms also. Okay, it is a ratio of the volume of voids to volume of solids. Porosity is the ratio of the volume of voids to total volume into 100%. And the range of the porosity is 0 less than n less than 100%. Okay. Now one more term included, one more idea included in the void ratio. I'm going to define. That's why I left the space between this porosity and void ratio. The space is here. So I'm going to write this one. The void ratio of fine-grained soil is greater than the void ratio of coarse-grained soil. Note it down. Very important. You just write like this. The void ratio of a fine-grained soil is greater than the void ratio of a coarse-grained soil. Okay. Fast. The void ratio of a fine-grained soil is greater than the void ratio of a coarse-grained soil. Okay. Why it is fine-grained soil void ratio? You can see. I will explain in a simple way. Suppose. Just see. I just took a soil particle. Okay, a soil like this having 9 particles. Okay, so the volume of solids is fixed. The same particles. Okay, the same particles I just took and I just powdered. Okay, I just powdered it and it is filled here. So same particle. Okay, same solid particle I just took and I just filled it after powdering. Okay, grind பண்ணி அது பவுடர் ஆக்கிட்டு இப்படியே fill பண்ணிட்டேன். So volume of the solid remains same, right? Because whatever amount of solid particles, that only I just powdered. Now if you are going to focus on the volume of void, anyway the ratio is volume of voids to volume of solid. So now I can see the space between these solid particles. The first case, it is very large. Okay, the space I will show in a red manner, in a red color. Okay, the space between the solid particles is very high, but the number of spaces is very less. Suppose if n is the number of spaces in the first case. Okay, in the first case n1, and now I am going to consider the volume of void here. See, the space between the solid particles is very less. The space is very less. That means the volume of one space is very less, but the number of volume is very, very high. That means number of void spaces, not volume. Number of void spaces is very, 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 very high. You can count n number of spaces. So n2. So n2 is very, very large compared to n1. That is what is n2? Number of void spaces in the second condition, which is greater than very, very greater than the number of void spaces than in the first condition. But the volume, if you are considering the volume of void in the first condition, one volume. Okay, one volume of void is very great, it is greater, but the number is actually very less. Okay, the number of void spaces in the first condition is very less compared to the second condition. That means, what is my verdict is, volume of voids in the first condition is less than the volume of voids in the second condition. That means E of second condition is greater than E of first condition. That means the void ratio of a fine grained soil is greater than the void ratio of a coarse grained soil. Okay. Suppose this is a, you can see some real life experiments. Suppose if you are going to if you are going to make rice flour, okay, so you are going to make a rice flour in a mill. Suppose initially you are filled this much amount of rice, okay, this is the raw rice, and after the grinding or after the powder flouring process, you can see the volume of the powder rice flour is very high. Okay, compared to this one, initial condition, the same rice only you powdered, but the volume get increased. Why volume increased? Volume of the solid same only here, but the void spaces is increased. Okay, void spaces increase. That's why the void ratio increased and the volume is also get increased. Clear? So that is why we have to say, for a fine grained soil, the void ratio is very higher than the coarse grained. Very not needed, higher than the coarse grained soil. This is the idea. Okay. So note it down. So next is actually the next term we have to check it out is second term, third term. It is degree of saturation. Degree of saturation. So degree of saturation is actually denoted by S suffix R. Okay, S suffix R. Now, please tell me what is degree of saturation. So S suffix R is the ratio of, who is going to tell? Sinju Bersi. Sinju, can you tell me what is a degree of saturation? Just tell me the ratio of what to what. Sinju, if you are there, please respond. Otherwise, Vinita. Any one of you, please respond. Just tell me randomly. If you know, if you don't know, just leave it.
The ratio between the volume of water to the volume of solids.
Volume of water to the
Volume of solids.
volume of solids.
Yes, sir.
Okay. Volume of water is actually, it's right. Degree of saturation, anyways, the saturation word is related to water. Okay, volume of water, but yeah, someone is actually texted me volume of water to volume of voids. Okay, Vinita, that is right. Okay, so the ratio is actually, it is volume of water to volume of void into 100. Okay, so the mistake actually, volume of water to volume of solids, that is not needed actually. Why we should know about the volume of solids in terms of volume of water? That is not actually not needed in terms of ratio. It is not needed. Okay, what we needed is how much amount of water is included in the void spaces. That is actually needed. Okay, that's why we define this degree of saturation. How much amount of water is included or inserted or exiting in the void spaces. Okay, so void spaces எவ்வளவு water இருக்கு, that is the degree of saturation. Okay, so simply you can remember like this: degree of saturation is related to water. So anyway we are dealing with the volume. So volume of water, water எங்க இருக்கு? Voids ல இருக்கு. Okay, so volume of water to volume of voids, that is degree of saturation. Now quickly we have to set the range. We have to set the range. What is the range of the degree of saturation? For a fully saturated soil, what is the value? For a fully saturated soil, what is the value of the degree of saturation? Just tell me.
100%.
Yeah, 100% fully saturated soil. That means the whole volume is filled with the whole volume of void space is filled with the water only. So volume of water become volume of void. So it is 100%. Degree of saturation is 100%. Now for a fully dry soil, it is zero. Absolutely correct. Because for a fully dry soil, there is no water, so volume of water is zero. So you can simply write degree of saturation is 0. So the range is 0 less than or equal to. Here you can write the equal to. Okay, because it's having value of 100% and 0. So 0 less than or equal to degree of saturation, that is less than or equal to 100%. This is the range of degree of saturation. Okay. Okay. Actually, may I know the name? Vinod, right?
Yes, sir.
Okay. So please mute. Okay. Now, along with the degree of saturation, I am going to define air content. Degree of saturation and air content are siblings. Okay, you can study like this. If you are going to study degree of saturation, along with you have to study air content also, because it is very simple to compare. Air content, as the name indicates, 1 minute. Okay. Please respond.
Yes,
Anyone? Yeah.
Yes,
Okay.
sir.
Okay. Fine. Thank you. Now, okay. Air content. See, air content actually I just said like it is a sibling of degree of saturation. So degree of saturation is actually whatever amount of water is available in void spaces. Okay, that is dealing with the degree of saturation. Air content means how much air is present in the void spaces. Okay, so air content I can simply write the volume of air to volume of void spaces. Okay, so you can see, you can compare these two things. Void spaces எவ்வளவு water இருக்கு, that is degree of saturation. Void spaces எவ்வளவு air இருக்கு, that is air content. Okay, so if you are going to add these, suppose if again air content is represented in percentage, I mean it's not in percentage, it's in value only. Sometimes it can be represented in percentage also. No worry. Okay, so degree of saturation plus air content, if you are going to add these two things, degree of saturation plus air content, it will become 100% or 1. Okay, this is the idea. Because if you are going to add degree of saturation with air content, you can see volume of void spaces, that is in the denominator, upon volume of water plus volume of air. Volume of water plus volume of air is nothing but volume of void only. So volume of void by volume of void, that is equal to 1. The relation between degree of saturation and air content, again it is very important. Now we are moving to the range. Okay, who is going to tell me the range? Okay, Vinod, again this is your turn. For a saturated soil, for a fully saturated soil,
Air content 0, sir.
air content is 0 because volume of air is 0. Okay, volume of air is 0, so air content is 0. Okay, for a fully dry soil,
Air content 100%, sir.
air content 100%. Now again, I am not going to represent in percentage, I am going to represent it digitally. So volume of it is 1. Yes. So volume of air is nothing but equal to volume of void. So air content is 1. Okay, so the range I am going to represent it like this: 0 less than or equal to AZ less than or equal to 1. Okay, so this is the range. So again, the final verdict is SR plus AZ, that is degree of saturation plus air content is equal to 1. It is very important. Now the last term in the volumetric relation, that is going to be percentage air voids. Okay, it is percentage air voids. Fifth one, percentage air voids. Now, what is percentage air voids? it is represented by N suffix A. I'm going to tell like this. This is volume of air. Anyway, it is air. Okay, percentage air voids. So volume of air, where? In the total volume. Okay, total volume air that is denoted by the percentage air voids, because volume of air by volume of void, that is already defined as air content. Now we have to know how much air is present in the total volume. Total volume air that is percentage air voids. So percentage so that is into 100. Okay, this is the idea. Now again I am going to define the range. So for a saturated soil, okay, so volume of air is equal to 0. So Na is equal to 0. For a fully dry soil, okay, for a dry soil, what you can say, volume of air, fully dry soil means whatever amount of void spaces is there, it is filled with your air. Volume of air is equal to volume of void. Okay, now volume of air is equal to volume of void. So volume of void divided by total volume, that is nothing but N, porosity. Okay, so Na become, see, for a dry soil, volume of air is volume of void only. So Na become volume of void divided by total volume into 100. That is nothing but porosity. Okay, so the range is actually, I can simply write 0 less than or equal to Na less than or equal to N. Upper limit is N, up porosity. Lower limit is 0. Okay, now one more relation I can define. N into, that is porosity into air content, that is equal to Na. You just check it out whether it is right or not. Okay, this is also important. Porosity NaC is equal to Na. N into AC is equal to Na. This is again an important relation. So these two relations, which are the AC plus SR is equal to 1 and NaC is equal to Na, these are very important. Okay, so we studied the 5 volumetric relations, that is void ratio, porosity, degree of saturation, percentage air voids, and air content. These 5 are very, very important. So that's why we took this much amount of time. Okay, because it will definitely give you 1 or 2 marks in this exam. I'm 100% sure. Definitely it will give in form of, maybe in form of problem or direct questions. Okay, now we will move to the water content, that is weight based. Okay, next is weight based relations. These are very important. Weight based. First is water content. Okay, water content. Now we will move in a fast way because these are very, very basic terms. Water content is represented by small w. Okay, so water content is defined as, even though it is basic, but it is important also, weight of water divided by weight of solid into 100. This is water content. See, suppose you are considering a soil, you know there are solid particles. Okay, solid particles and the solid, in between the solid particles there are water. Okay, so water is filled in between solid particles. Now you consider the weight of the solid particles. Weight of the solid particles for a soil is constant actually, right? Weight of the solid particles is constant for a soil. Suppose if this soil is undergone compaction, again solid particles, same solid particles is available there. So weight of the solid particles doesn't change. But suppose if you are going to apply some heat here, okay, you applied some heat here, and after heating or after drying, the solid particles remain same as it is, but the water content, it get reduced, or the water get reduced. during the oven dry. Okay, so the weight of the solid particles is same here. The two conditions, the weight of the solid particles is same, but the weight of the water WW1 here it is WW2, it is not same. Okay, again this water content become a major property, major definition, like your void ratio. See, in the void ratio you are creating volume of voids to volume of solids. Volume of solids is constant. Here weight of solids is constant. You are comparing the weight of water in different conditions for a soil. Again, if you know the water contents in different conditions of soil, you can simply say what is the condition of the soil. Okay, that is the idea. So anyway, water content is nothing but the weight of water to weight of solids. This is very important. Now I should know what is the range of the water content. Water content range. It can be 0 because for a fully dry soil there is no water. For a fully dry soil there is no water. Okay. Okay. So this one is water content. Okay. Where we stopped, actually, yeah, range, where it can be the upper value, where it is limited. Okay. So water content for a dry soil, actually, you know, water content for a dry soil, it will be 0. Yeah, yeah. Why it is? Because there is no water, so weight of the water is absolutely 0. So no doubt in that one. So it is 0. Okay. Now for a fully saturated soil. Okay, this is fully dry soil. Fully dry soil. Okay, for a fully saturated soil, what is the condition? We know water content is equal to
1, sir.
Percentage into 100. So
100.
100%. Okay, into is equal to 100%. Is this the only condition for fully saturated soil? Because I am again asking, for a fully saturated soil, water content should be 100%. Okay, water content is equal to 100%. Any other situation is there occurring if water content can it be less than 100 or can it be greater than 100 for a fully saturated soil? அது வந்து fully saturated soil பொறுத்த வரைக்கும் water content எப்பவுமே 100% மட்டும்தான் அந்த மாதிரி இருக்கா? Can it be below 100%? Can it be above 100%? Vinod, just think. எப்பொழுதுமே for a fully saturated soil எப்பொழுதுமே இது water content 100% இருக்குமா?
இல்ல சார்.
இல்ல. See,
partially saturated இருக்கும்போது கம்மியா இருக்கலாம் சார்.
இல்ல, I am saying for a fully saturated, say my soil condition is actually fully da. Okay, what the whole void space is filled with the water itself. Okay.
Okay.
அந்த சிச்சுவேஷன்ல வந்து வாட்டர் கண்டென்ட் எப்பவுமே 100% அந்த மாதிரி எனக்கு சொல்ல முடியுமா இல்லையா? லைக் அதுல வந்து சம்டைம்ஸ் மேபி இஃப் ஐ எம் டேக்கிங் த வெயிட் ஆஃப் வாட்டர் ஃபார் அ ஃபுல்லி சேச்சுரேட்டட் soil, I am just taking the weight of water. Okay, weight of water maybe 100 gram. Sometimes, okay, weight of the solid, when I calculated, it become 90 gram. See, for getting a water content up equal to 100%, you need to take it as weight of the water should be equal to weight of the solids, right?
Yes, sir.
But everywhere it need not be satisfied, because sometimes the weight of the solid particles maybe is less denser, so the weight may be weight may be very less. Sometimes the weight of solids is very denser, weight may be sometimes 200 gram. Okay, if you take the water content in this condition, so 100 gram divided by 200 gram, you will get 50%. Okay, suppose in some condition it will be weight of the solid particles, suppose 100 itself. So weight of the water divided by weight of the solid, it become 100%. In the second condition, it may be again more than 100%. So what I'm going to say is, for a fully saturated soil, water content can be less than 100%, equal to 100%, can be greater than 100%. So I am going to say the range of a water content will be greater than 0, greater than or equal to 0. This only I can say, because I cannot fix the upper limit. It can be 100% or it can be above 100%. Are you getting my point?
Yes, sir.
Yeah. So that is very important, because for a fully saturated soil, the water content for a fully saturated soil, water content can be 100%. It can be greater than 100%. It can be less than 100% also, because we are comparing the weight. Okay, for a fully saturated soil, the volume of water is equal to volume of the void. Volume based comparison, it is okay. Volume of water equal to volume of weight. That is okay. But the weight of water and weight of soil is need not be equal to same. Okay. Okay. It can be equal. It cannot be equal. രണ്ട് condition വരാം. Okay. So weight of the water, weight of the solids equal വരാതെ sometimes for a fully saturated soil. Again, I am going to say one more statement. See, like this: for a fully saturated soil, So this is our condition for a fully saturated soil. Water content, please note it down. Water content need not be equal to 100%, even though its degree of saturation is 100%. So ഒരു soil പൊറുത്തവരേക്കും degree of saturation 100%. It doesn't mean its water content is 100%. It can be 100%, it can be greater than 100%, less than 100% also. Okay, so that is a condition, that is a statement, very important statement. Okay, so now the next term actually we have to focus on, that is unit weight. Very important term, unit weight. Unit weight is nothing but, we can simply say, generally it is termed as gamma. Okay, gamma. So gamma is weight divided by volume. Okay, generally it is termed as weight divided by volume. So weight means the weight of the soil. W is the total weight of the soil, and V is the volume of the soil. Okay. So gamma value is weight divided by volume. So actually what does it mean is, in a particular volume, particular volume of soil, how much weight is occurring. Okay, suppose if you are taking a 1 centimeter cube of soil, what is the weight of it? Okay, so in a unit volume, எவ்வளோ weight இருக்கு? So that is the unit weight. Okay, so that is simply, you can say, it's the total weight per unit volume. Total weight per unit volume. That is the idea. Total weight per unit volume. What is the importance of this one? Because if you know different soil having different unit weight, suppose gamma 19.2 kilonewton per mm cube. See, the unit is actually kilonewton per meter cube or mm cube. Okay, so here I am meter cube, kilonewton per meter cube. Okay, so weight is generally, even you can term it as Newton per meter cube. Okay, weight is generally, it is in Newton, volume is in meter cube. Okay, again you can say, suppose weight in gram per centimeter cube. Again it is a unit, gram per centimeter cube, and ton per meter cube. These are all unit weight that we will see. Okay, anyway, gamma is equal to weight by volume, total weight by unit volume. So suppose gamma 1 for a soil is 19.2, gamma 2 is 20.5 kilonewton per meter cube. So two soils are there of same volume. Okay, same volume of soil with the two different value of gamma. So by analyzing these two, I can simply say the gamma 2, the unit weight of this one is very high. That means the weight of the soil is more. Okay, weight of the soil is more. That means the solid particles is very dense. Okay, solid particles is very dense. Okay, compared to this soil. So solid particles வந்து heavier இருக்கு compared to first soil. That's why it's having more weight in the soil. So weight of the soil, what is weight of the soil? Total weight, that means W means weight of the solid particles plus weight of the water. If it is a partially saturated soil, weight of the solid particles plus weight of the water plus weight of the air also. But we are not considering weight of the air, it is negligible, divided by volume. So this is your unit weight. So if you are considering the unit weight, that is total weight by volume. Okay, total weight by unit volume. The total weight means the total weight of the soil. The total weight of the soil, that means weight of the solid particles plus weight of the water. This thing you should know, because for a fully saturated soil, weight of the solid particles plus weight of the water. Okay. Audible and green is okay.
Yes, sir. Audible and visible, sir.
Okay. Sorry guys, actually my system having some problem. I don't know what is happening. Anyway, we will continue.
That's okay, sir.
Where we stopped? Yeah. Okay, unit weight, right? Okay, we'll continue. Okay, so what is unit weight? Actually, it is weight by volume. Okay, it's a simple term. It's weight by volume. So what you need to know is actually in the weight, what is there? Weight is actually weight of the solid particles plus weight of the water. Weight of the air is no need to take up because it is very negligible. So that is in the case of a partially saturated soil. Okay, partially saturated soil. Okay, so it is weight of the water, weight of the solid plus weight of the air is there. Okay, weight of the air is there, but we are not considering. For a fully saturated soil, it becomes weight is equal to weight of the solid particles plus weight of the water. Again, it is same like partially saturated, but so this is a partially saturated and this is a fully saturated. So which weight will be more? We know. Suppose this is for a same soil. I am considering two conditions. Okay, one is partially saturated soil condition, another is fully saturated condition. I am taking the weight of partially saturated weight as WP and fully saturated it is WF. Which one is more?
WF, sir.
WF, because weight of the weight of the solid particles, the weight of the water, actually the complete void spaces is filled with water. Okay,
Yes, sir.
the weight of the water will be more compared to in this first condition. So the weight of the fully saturated soil is more than the weight of the partially saturated soil. Okay, what about the dry soil? Dry soil is nothing but the weight of the dry soil is nothing but the weight of the solid particles only. There is weight of the air, but it is negligible. So WD, that means the dry weight is weight of the solid particles only. Okay, so WP, which is less than WD. WD is the smallest thing because there is only weight of the solid particles. So weight of the solid particles for a dry soil, for a fully saturated soil, weight of the solid particles plus weight of the water. The complete void spaces is filled with water, so that weight is more. For a partially saturated soil, weight of the solid is there, weight of the water is there, but the again air is there. Okay, the void spaces are not fully filled with water. The void spaces are filled with water and air. That is a scenario. Okay, so you are getting an idea about the weights. Okay, now we are moving to the gamma value. So what is gamma value? That is unit weight. But this is a general term, unit weight. Now we are going to specifically define the unit weight of each term. Okay, each one. That means first, suppose you can define unit weight for anything. Okay, suppose now you have the pen with you. Okay, you can define unit weight of pen. In order to find out the unit weight of pen, you have to find the weight of the pen and you have to find the volume of the pen. And you can divide it as W by V, you will get the unit weight of your pen. That means the pen actually, suppose it's a cylindrical shape. Okay, so cylindrical shape, so the volume you are going to find, okay, the cylindrical shape pen, you are going to find out the volume and you are going to find out the weight. Then you will get the weight by volume. So in unit volume, how much weight is there for a pen? That is the gamma value. For a unit volume, how much weight? Suppose you have a pen and you have a book. Okay, so you are taking the gamma of book. So gamma of book means the weight of the book divided by volume of the book. Now likewise, I'm going to find out the unit weight of different soil. Okay, so first I'm going to define unit weight of saturated soil. Okay, unit weight of saturated soil. Unit weight of saturated soil. This is very important, saturated soil. So it is denoted by soil. Okay, saturated soil. It is denoted by gamma sat. Okay, so gamma sat is nothing but unit weight எல்லாமே weight by volume தான். Okay, so weight divided by volume. You can define everywhere. It's like weight by volume, weight by volume, weight by volume. So weight of what? Weight of saturated soil. Weight of saturated soil means weight of the solid particles plus weight of the water divided by V is what? Volume of the soil. Okay, volume of the soil. Now I am going to define unit weight of dry soil. Okay, unit weight of dry soil, that is gamma D. Gamma D. This is very important. Okay, gamma D. Again, I am going to simply weight by volume. Weight by volume. What weight? That is dry weight. Okay, that means dry weight means weight of the solid particles only. So weight of the solid particles divided by volume of the soil. Weight of the solid particles divided by volume of the soil. Now gamma D means weight, unit weight of dry soil. That means gamma D is equal to weight of the solid divided by volume of the soil. Suppose I need to find out gamma D of a saturated soil. Confusion ayirka? Gamma D of a saturated soil. Is it possible to find out the gamma D of a saturated soil? Yes, because as per definition, gamma D is nothing but weight of the solid particles divided by volume of the soil. You need to find out, if you are taking a saturated soil, you just consider the weight of the solids there, then you just consider the volume, then you will get the gamma D value. So gamma D value, you can again find gamma D value of a fully saturated soil, gamma D value of a partially saturated soil. Okay, so gamma D பொறுத்த வரைக்கும் gamma D dry soilக்கு மட்டும் அந்த மாதிரி ஒரு thought process போகக்கூடாது. Gamma D can be find out for a fully saturated soil, for a fully dry soil, for a partially saturated soil itself. Okay, that is the idea, because as per definition, it is weight of the solids divided by volume only. Okay, weight of the solids you can find out any soil. Okay, are you getting my point? So weight of the solids can be find out for any soil. So in that way, you can find out the gamma D value for any soil. Any soil means whether it is saturated, whether it is dry, whether it is partially saturated. But gamma sat means that is a saturated unit weight that can be found for saturated soil only. Okay, so saturated soil, I just find out the unit weight. For a dry soil, again, even dry or saturated or partially saturated, you can find out the gamma D value. Now I am going to find out specific gamma value of partially saturated soil. That means it is called bulk unit weight. Bulk unit weight of soil. It is nothing but, it is generally represented by gamma. It is nothing but, it is the unit weight of a partially saturated soil. Keep it in mind. If it is a unit weight of a partially saturated soil. With partially saturated soil, you have to find out the gamma value. What is the difference? Again, you can write weight by volume. But in that weight of the solid particles plus weight of the water plus weight of the air will be there. But it is no need to consider divided by total volume. Okay, so bulk unit weight, gamma. Okay, if you are going to hear any word about bulk unit weight, okay, if you are going to see any question regarding bulk unit weight, you have to remember that it is for a partially saturated soil. Okay, so gamma is for a partially saturated soil, where it is the weight by volume, weight of the solid particles plus weight of the water plus weight of the air divided by volume of the soil. Okay, so gamma D, gamma and gamma sat. One more time is there, that is submerged unit weight. Submerged unit weight. Submerged unit weight is nothing but suppose the soil is submerged condition. Okay, suppose the river bed, as I said earlier, this is a river and I just consider this soil. This is in a submerged condition. Okay, in a submerged condition, gamma sub or gamma dash, it is nothing but, you can simply write, it is gamma sat minus gamma W. Gamma sat minus gamma W. This is submerged unit weight. Okay, so these are the major unit weights. One more unit weight is there, that is nothing but unit weight of water. I said earlier, you can define any unit weight. Okay, unit weight of water, unit weight of solid particles, unit weight of soil, anything. Okay, unit weight of air. So, unit weight of water, you will see unit weight of water. Unit weight of water. It is denoted by gamma W. It is denoted by gamma W. Gamma W is nothing but, again, weight by volume. Weight by volume of what? Weight of water divided by volume of water. Okay, weight of water divided by volume of water. Just like weight, unit weight of pen is weight of pen divided by volume of pen. Unit weight of saturated soil is weight of soil divided by volume of the soil. Unit weight of dry soil is weight of dry soil divided by volume of dry soil. Unit weight of submerged, partially saturated soil is weight of soil divided by volume of soil. Unit weight of water is weight of water divided by volume of water. Okay. Now, again, I am going to define one more unit weight. Unit weight of solid particles. Okay, solid particles in the soil. Okay, solid particles in a unit weight. Gamma S, that is denoted by gamma S. How you can define? It is a ratio of weight of solid particles divided by volume of solid particles. Simple. Okay, weight of solid particles divided by volume of solid particles. That is nothing but unit weight of solid particles. Okay, unit weight of solid particles or unit weight of solids. Solids means solids contained in the soil. Okay, so gamma W, it's generally what the value is. If you are going to take the value weight of water divided by volume of the water, you will get 9.81 kilonewton per meter cube. Okay, that means it is, suppose it is in gram, 1000. Okay, 1000 kilogram per meter cube. Okay, again it can be 1000 into multiply with 9.8, you will get a 9.8 into 10 raised to 3 Newton per meter cube. That is written as 9.81 kilonewton per meter cube. Okay, again one more unit is 1 gram per cc. This is also another unit, 1 gram per cc. Again you can define it is same as 1 ton per meter cube. These units are all same, 1 gram per cc, 1 ton per meter cube. Okay, or 1000 kilogram per meter cube, that is equal to 9.81 kilonewton per meter cube. Approximately, sometimes you will take it as 10 kilonewton per meter cube. Approximately, it's not exact. Approximately, it is, you can take it in problems as 10 kilonewton per meter cube. This is the unit of value of gamma W. It is very important. It is very, very important. Gamma W. Gamma W is equal to nothing but weight of the water divided by weight, volume of the water. Okay. Now I am going to consider the gamma S. Okay, gamma S is weight of the solids divided by volume of the solid. Okay, by comparison, ഒരു comparison check பண்ணும்போது gamma, no. Yes. Okay, so I am just comparing these values. While comparing, I can see, first I will write, then we will explain. Okay, so gamma S value is more compared to gamma sat, compared to gamma and compared to gamma D. This is my opinion regarding these gamma values. Okay, this is my opinion. So we will check whether it is right or not. Okay, So see, gamma S is always greater than gamma such, gamma and gamma D. Why it is? Because see, gamma S means weight of the solid divided by volume of the solid. Suppose if you are considering the three-phase diagram of a partially saturated soil, this is the volume of the solid, okay, and weight of the solid, you are just considering the weight of the solid here, and the ratio is weight of the solid divided by volume of the solid. It is the gamma S value. Suppose if you are going to consider the gamma sach for the same soil, so gamma sach is, that means weight of the soil divided by volume of the soil. See, denominator is actually volume of the soil, the total volume. Okay, so total volume. Denominator here, it is volume of the solids in case of a gamma S. Gamma S is equal to weight of the solids divided by volume of the solids. Volume of the solids is very, very less compared to the total volume. Total volume, if you are considering the total volume, volume of the solids is less. So denominator is less. So numerator is, I mean, this ratio is high. Okay. So gamma S is high. Denominator is decreasing. So gamma S is increasing. So compared to the other terms, gamma sach, gamma D, the whole denominator is total volume only. Whole denominator is total volume. But gamma S, it is volume of the solids. Okay. So it is less. So gamma S is more compared to gamma such, gamma D. Gamma such, gamma D, already we compared the weight, right? The previous slide, we compared the weight, right? I will show you. Yeah, here we compared, this is weight of the fully saturated, weight of the partially saturated, dry weight. If weight is comparing like this, gamma value again, because volume, the total volume of the soil is same. So gamma of saturated is greater than gamma D. That only I wrote here. Where? Yes. Okay. So this is very important. You just note it down. It can be asked. Okay. So gamma S is greater than gamma such, greater than gamma D. This is the idea. Okay. So next our term is.
Sir, then what about the range in between the gamma sub?
Which one?
Gamma sub, sir.
See, gamma submerged, you can see it is simply gamma sach minus gamma W, right? So anyway, it is less than gamma sach. Okay, less than gamma sach. Sorry.
Can you note down the relationship in the range?
Sorry, I didn't get your question again. Once, can you tell me one?
Can you note down in the range in between gamma sat or gamma W?
See, why we are not considering gamma S, gamma sach, gamma D, and gamma submerged. It's always depends on the gamma W value. Okay, gamma W is, say, suppose anyway it is making to 9.8 kilonewton per meter cube. Okay, now just suppose if water is present in the all soil condition, you can compare like this. Suppose if other conditions it may happen. Suppose gamma value, it is nothing but, that is weight of the solid particles plus weight of the water plus weight of the air divided by volume. Okay, so gamma submerged, it's always be, suppose if you are taking a weight in a submerged condition, you will feel less weight. Okay, less weight compared to your original weight. That is not because of the Bion effect. Okay, that's why gamma submerged is always gamma sach minus gamma W you are taking, because there is an uplift. Okay, there is an up force acting on the weight. The downward weight is like acting like this. There is an upward weight. By calculation, if you are just going to the steps, you can finally arrive at gamma dash is equal to gamma sach minus gamma W. So while we are taking this consideration, this comparison, so I can simply write gamma S is greater than gamma sach. Suppose comparing with gamma submerged, it is very less. Okay, gamma submerged is very less, and it is a directed value. Like gamma sach means gamma sach is value always it's deducting, that is 9.8 kilonewton per meter cube is deducting. So I cannot compare it with gamma, because gamma value having maybe gamma sach and gamma W, and gamma value, it always depends on the weight of the solid particles. Suppose if it is very, very high dense material, then gamma W is always fixed. Okay, suppose weight of the solid is very, very less. Okay, sometimes gamma can be greater than gamma submerged. Sometimes gamma submerged can be greater than gamma itself. Okay, it can be. But you can compare with the gamma sach and gamma submerged. It is always gamma sach greater than gamma submerged. Okay, with the comparison with the gamma, it can be because gamma value is always depends on the, if suppose the same volume, weight of the solid particles plus weight of the water. Okay, so weight of the solid particles, if it is very higher, if it is very denser, then gamma may be greater than gamma sach. If it is very less, if the water weight is more, can be gamma submerged can be greater than gamma. It depends. That's why I am not considering here the general comparison in the, these are all relative term. Gamma submerged is always relative term. Relative term in the sense it depends on the water. It's dipped in the water. So effectively you will get the gamma sub value. Okay, are you getting?
Yes, sir.
Okay. For comparison, you can say gamma sach is always greater than gamma submerged because it is very less. Okay, because it is difference is actually gamma W value. So next one, I am going to consider the gravity, specific gravity. Specific gravity. So that is G. It's a very important term. So G is nothing but, specific gravity is nothing but gamma S divided by gamma W. Okay, there are two specific gravities. One is true specific gravity, and second one is apparent specific gravity. Apparent specific gravity or mass specific gravity. Mass specific gravity. So that is GM gamma divided by gamma W or gamma sach divided by gamma W, or I can define gamma D divided by gamma W. See, we will see the differences. Okay, first one, true specific gravity. True specific gravity means it is a ratio of gamma S. What is gamma S? Gamma S is nothing but the unit weight of solids. Unit weight of the solids is weight of the solid divided by volume of the solid. For a soil, gamma S is actually its address. It's permanent address. It doesn't change. See, weight, or soil one, the weight of solids is same, the volume of solids is same. So this by this is actually it's a constant for a soil. Unless you are not going to take any solid particles from there, or you are not going to add any solid particles, in that condition, gamma S is same. So gamma S is a constant or a fixed value for a single soil, and you are comparing the gamma S value with a gamma W, that is the unit weight of water. Unit weight of water actually we are taking as a standardized value. So ஒரு ஸ்டாண்டர்ட் வேல்யூன்னு பொறுத்த வரைக்கும் எவ்வளோ வெயிட் அதிகமா இருக்கு அந்த வேல்யூ தான் G. Okay, so standard value of gamma W that we know, suppose 10 kilonewton per meter cube. Okay, suppose I am saying the true specific gravity is 2. That means I am getting an idea of the G value. If G value is 2, that means my soil is 2 times heavier than the water. Okay, 2 times heavier than the unit weight of water. Suppose if it is 3, I am getting a feel like it is 3 times heavier than the water. Okay, what? The solid particles. Okay, the solid particles is heavier than water. That indication is given by the specific gravity, true specific gravity. Okay, so true specific gravity, this gamma W is actually is taken for a distilled water, pure water at 4 degrees Celsius. Okay, that is very important. This temperature is very important because if the temperature is changing, the gamma W value may affect it. So standardized value is 4 degrees Celsius gamma W, that is 1000 kilogram per meter cube or 9.81 kilonewton per meter cube. That is taken as the standardized value by compare for what? For comparing the density, how much denser the solid particles is. That is true specific gravity. So true specific gravity doesn't change. For a soil, it is a constant value. For a soil, it is a constant value. But the apparent specific gravity or a bulk specific gravity or a mass specific gravity denoted by GM, it is not a constant because it can be considered for different conditions. See, comparison just gamma divided by gamma W, that is for a partially saturated soil. Gamma sat divided by gamma W, that is for a fully saturated soil. Gamma D divided by gamma W, that is for a fully dry soil. So different soil condition, you can define the different specific gravity, apparent specific gravity. Okay, apparent specific gravity or mass specific gravity. So G and GM, you can compare G and GM. G is always greater than GM. G is always greater than GM because we know G is gamma is by gamma W. GM is gamma by gamma W or gamma such by gamma W or gamma D by gamma W. We know gamma is always greater than gamma such gamma D. Gamma such gamma D எல்லாமே compare பண்ணும்போது gamma is the top or higher value. So that means G is always greater than GM. Okay, keep it in mind. G is greater than GM. True specific gravity is actually the permanent address of a soil. Mass specific gravity is a temporary address of a soil. Okay, that is a differentiating idea for you. G and GM. It's very important. Okay, true specific gravity. Suppose sometimes the question will ask like the specific gravity of a solid particle, specific gravity of the solid element, specific gravity of a soil particle. These are all true specific gravity only. What are they? Specific gravity of a solid particles, specific gravity of a soil particle, specific gravity of soil elements. These are all true specific gravity. But apparent specific gravity, that is defined for the specific gravity of a soil in bulk condition, or specific gravity of a soil in saturated condition, or specific gravity of a soil in dry condition. These are all apparent or mass specific gravity. Okay, are you getting my point? So true specific gravity is only for solid particle comparison. Solid particle on our. Okay, solid particle is there. Gamma is by gamma W. Okay, gamma is by gamma W. So the question may ask in different way. The specific gravity of solid particles, that is nothing but G. Specific gravity of solid elements, that is nothing but G. Specific gravity of soil particles, that is nothing but G. Okay. And apparent specific gravity is defined like the specific gravity of the soil in bulk condition, the specific gravity of the soil in saturated condition, the specific gravity of the soil in dry condition. This is the different specific gravity. Okay. Now I'm going to define some important relations.
Sir,
yeah.
Is there any temperature is there for conducting for a specific gravity, sir?
Sorry. One more.
What is the temperature for water, sir? Here, apparent specific gravity.
Yeah, it's gamma. Yeah. It is 4 degrees Celsius only. See, everywhere the standard value for gamma W is whatever we are going to take 1000 kilogram per meter cube or 9.81 kilogram. That is at 4 degrees Celsius only. Okay, that is the standard value. Distilled, actually gamma W for a distilled water, pure water we call. Okay. The only change is gamma values. The numerator is changing. Okay.
Fine, sir.
Okay, fine. So next we are going to see some important relations that is very important for you, because in the 2019 I think they asked a question about to find, I think it is porosity or something, void ratio something. Okay, so for that one again they asked for gamma value also. So in order to find that values, you need to know some relations that is very important for you. You have to mug up those relations. Okay, it's very simple. First relation is actually E is equal to Wg by S. You know all the time E is the void ratio, W is the water content, G is the specific gravity. G means true specific gravity, not apparent. Okay, S is the degree of saturation. The second relation is actually gamma is equal to G plus SC into gamma W divided by 1 plus E. This is another relation. Actually, the whole relation is coming from the basic idea of weight divided by volume. Okay, weight divided by volume. From this only they are deriving these equations. Okay, no need of derivation and all. You just by heart these equations. The third one is gamma sag. Suppose if you know this equation, G plus SC into gamma divided by 1 plus E. Okay, so a simple trick is gamma sat means saturated, degree of saturation is 1. So you can simply simply write this equation as G plus E into gamma W divided by 1 plus E. So for our easiness, okay, for our study, actually you can simply write S is equal to 1 here. Okay, for a fully saturated soil, you know degree of saturation is 1. So you will get the G plus E into gamma W divided by 1 +. Actually, from the derivation point of view, it is not right. Okay, from the derivation point of view, is actually there is a steps. Okay, like gamma sat is actually weight of saturated soil divided by volume. From here only it starts, not from giving S is equal to 1, you will get this equation. That is not correct. But for our study, for making it is easier, we are giving S is equal to 1, because you need to study only this equation. You can derive, I mean, you can arrive this equation, not derive. Derivation is different. Okay. So fourth one is actually gamma D, again gamma D value. For a gamma D, that is dry condition, you know S value is 0, degree of saturation is 0, there is no water. So you put the value of 0 here, you will get a G into gamma W divided by 1 plus C. Again I am saying, you will get this G gamma W divided by 1 plus C by taking your initial condition gamma D is weight of the soil divided by volume of the soil, not from this equation. Okay, if you are putting S is equal to 0, anyway you will get G gamma W 1 plus C, but our derivation is something different. Okay, but for our easiness of study, you can put 0 here. So G gamma W divided by 1 plus C. It is very simple. So by knowing only one equation, you can derive. No, again, I am not saying derive. You can arrive another two equations. Okay. So one more equation is there. Gamma D is equal to gamma divided by 1 plus W. This is another equation, important equation. Actually, see, one thing I am going to share is, see, gamma D, I already told you, no, gamma D is actually dry unit weight, right? Unit weight of a dry soil. But by seeing this equation, it is gamma divided by 1 plus W. W means water content. So water content means water is there in the void ratio, sorry, void spaces. So how it's going to be affecting gamma D? Some confusion is arising for you know now, but for you people, there is no confusion, because I know, or we know, gamma D can be defined for any soil. Gamma D, that is dry unit weight, can be defined for bulk soil, that means partially saturated soil, because we are considering only weight of the solid particles divided by volume of the soil. That's why you can put in that equation water content is coming. Some students having some doubt, like how a water content is coming for a calculation of gamma D value. Some kind of confusion is coming for some students, but you guys, you don't need to get confused, because already we studied, because gamma D can be defined for any soil. Okay, so these 5 equations you need to study very well. These are the basic equations, and this they can ask. Actually, I think last 2019, based on this equation or this one, I think they asked one question. Okay, one simple problem. I will share to you that question in coming classes. Okay. Now, so these are the 5 equations. Please study. It's very important. Now we are moving to the experiments. Okay. So only thing is, 1 minute. Yeah, I just want to open my PPT. Actually, PPT is better. The whiteboard, whatever we studied, that is whiteboard. Actually, it is only crashing. I need to open it in another PPT. That would be better, I think.
Sir, porosity or percentage of air voids. இது ரெண்டுத்துல ஏதாச்சும் ஒன்று நெகட்டிவ் போறதுக்கு சான்ஸ் இருக்குமா சார் வேல்யூ?
நெகட்டிவா?
நெகட்டிவ்ல.
No way, man.
No.
Because you just think porosity, no, it's volume, no?
It's a volume of voids to the total volume.
Yeah. Then there is no need of negative sign, no? Negative sign means there should be some decrease. I mean, come in where actually negative sign came. The value should be negative means it should have to be decreased. By comparing the two different values. Suppose if it is like the ratio will be like V minus or V volume of voids minus volume of solids divided by volume, something like that. Okay, அந்த மாதிரி ஒரு relation இருந்தா there may be chance of negative, and even some comparing, that is means the negative signs always coming in the comparison. Okay, comparison means there should be some difference in the numerator in most of the cases. And
Okay,
some,
sir.
see, keep it in mind, some cases, suppose if you are studying in Skempton's parameters that is coming in the shear strength, some empirical equations are there. In empirical equations, it can be negative, some equations that you will see in the future chapters. Okay, some
Okay.
A value, B values are, so A can be negative, and some, that is a different scenario, because those are all empirical formulas. So A can be assigned any value.
Okay. Okay.
For here, the condition is actually, you just get an idea like the volume is volume of void divided by total volume. So these are ratios. Anyway, it will be always positive. So the next thing you asked about degree of saturation, right? That is volume of, or degree of saturation or percentage air voids.
Both are, sir.
Both
I'm
are, okay,
asking.
whatever it is, whatever it is. So degree of saturation is volume of water to volume of void. Again, volume of water will be there. That is a positive value, volume. Again, denominator, again, it's a total volume. Again, it's a positive value. So for a relation or ratio kind of these things, they are not, need not be think about the negative value. Okay.
Okay, sir.
Yeah.
Sir, in somewhere I have studied E should not, I mean, E should not less than 0.35. Is it right or not, sir?
E should not be less than
0.35, sir.
Yeah. There is some, that we will study in next slide. I mean, next topic, because E
Okay.
actually, that I will show, because when we are considering the solid particles are spherical, okay, spherical
Okay.
shape, it's not actually true. So solid particles have a different shape, but for our study, for our analysis, we will consider it as a spherical shape. And while we are arranging the spherical particles in a particular way, you can arrange in different way, because a compact form arrangement is there, and even a liberal form of arrangement here. In that way, if you are considering the compact, that means if you are arranging it in a diagonal way, that I will show in a figure. If you are arranging it in a diagonal way, you will get a compact form of arrangement, and there the E value will be minimum.
Okay, sir.
That value is actually 0.35.
Fine, sir.
Okay.
Could you
If you
explain the
are,
next slide, sir?
if you are arranging it in a loosest packing, that means in a liberal way, actually it's a space is there, then the E value will be maximum. That
Okay.
value will be 0.991.
Yes, sir. So the E between the 0.35 to
Yeah,
0.91.
E is 0.35 to 0.991 for a spherical particle. We are considering the particle as a spherical. Clear?
Okay, sir.
That I will show you. That I will show in the last topic. Okay. So now I am going to share my slide. I am just open my PPT. Wait. Okay. So what about Kamala, Vinita? Do you have any doubt? You can ask in Tamil. Okay.
Clear, sir. Everything is clear, sir.
Can I ask question for you if it is clear?
Sure, sir.
Okay. Next time. What about Vinita? Are you okay? ഇതുവരെയ്ക്കും okay തന്നെ? Vinita, if it is okay, please tell me yes in chat box or unmute yourself. Okay, I'm going to share.
Sir, one more thing, sir.
Yeah, tell me, man.
Sir, gamma DO, bulk in, I mean, dry unit weight, bulk unit weight, equal ஆக chances இருக்குல்ல, sir?
Dry unit weight, bulk unit weight for a same soil பொறுத்த வரைக்கும் it cannot be equal.
Yes, sir. Same soil cannot be equal, sir.
It cannot be equal. How it is? You just think, suppose same soil na இப்போ வந்து நம்ம வந்து அந்த soil உள்ள spaces வந்து same தானே?
Yes, sir.
அப்போ அதில் வந்து ஒரு bulk unit weight, that means for a partially saturated soil அந்த spaceல வந்து யாரெல்லாம் இருக்கும்? Water and air.
Fine.
So next scenario, okay, I will show it in the slide. So the slide is actually visible for you. I'm going to show you the scenario what you asked in using a picture. See, this is your solid particles for a soil. Okay, this is the soil particles, and the space between them is actually what is called the void spaces. Now, first condition actually for the same soil, first condition is actually it's a partially saturated soil. So I know partially saturated soil, some amount of water is filled in between the soil particles, the space between the soil particles. Okay, this much amount of water is there. Okay, now I just going to oven dry this soil. Okay, oven dry this soil, so I will get a soil like this. The same soil particles will be there, same soil particles. Okay, so now the water is not there. Okay, water is not there. In the initial condition, water is there. Now I am going to define the gamma value. Gamma is actually weight of the solid particles plus weight of the water. Weight of the air need not be considered, divided by volume of the soil. It is same. Here I am going to find out the gamma D value because it is a dry condition. So it is weight of the solids divided by the volume of the soil. Volume of the soil, here it is same, but here numerator, weight of the solid plus weight of the water is coming here. Here weight of the solids only, weight of the water is not there. So gamma is greater than gamma D. Vinod.
Yes, sir.
Okay, but for a different soil it can be happen because it always depends on the value of the weight of the solids. No, suppose the for a different soil, so weight of the solids plus weight of the water, suppose it is 20 gram, the same weight maybe can be happen for the weight of the solids because the solid particles may be denser than this. First condition second condition weight of the solids கொஞ்சம் denser ஆயிருந்தா 20 gram
Yes,
can
sir.
be achieved
The same thing.
for different soil. But for a same soil, for same volume, if you are considering the gamma and gamma D value, it will be different.
Okay. Fine, sir.
Okay, the idea should be clear because gamma means actually it's water will be there in the partially saturated soil. Anyway, water will be there. Gamma D means we are only taking the solid particles. You are only considering the weight of the solid particles.
Okay, sir.
Even though I am not going to dry up these things, no. Suppose if I am not going to dry up, even though I can find out the gamma D of this one also. I need not to consider the this is a dry soil because I need to pick the weight of the solid particles alone. Weight of the solid particles mattum consider panni divided by volume. Now you will get the gamma D. Okay.
Yes, sir.
Okay. So why I am taking this much time to deliver these topics, because anyway you are going to get 2 marks from this topic, 2 or 1 marks from this area, but this is a foundation thing or foundation topics for the remaining areas, because without knowing these ideas or these concepts you cannot follow it into next topic, and even you cannot study geotechnical engineering itself. Okay, so that is why we are taking this much time, but for the coming chapters we don't need to take this much of time. So I'm going to I'm going to move to the next area, that is our
Sir, is there any more relationship in between this, sir?
which one, man? Yeah, one more relation is there that I am going to give you on the compaction chapter. Okay,
Yes, sir.
because it is actually very simple relation, gamma D equation only. Actually equation is like this: 1 minus Na into G gamma W divided by 1 plus Wg. That is again one important relation, but it's better to study in this compaction area because you will connect the equation with more concepts. Okay, you can connect this, but here you cannot connect. You can simply mug up this equation: 1 minus Na into G gamma W divided by 1 plus Wg. My recommendation is actually you should study it in the compaction chapter, and you can mug up this equation there. Okay, if you need to write this equation in your important relation, you can write this one, no worry, but you have to study there only.
Fine, sir.
Okay, now you can arise some relations. Before moving to experiment, I will tell you some relations. That means by comparing some values, volumes of different soil, I will share you some relations. That means, suppose if I am going to consider the gamma D value, gamma D is nothing but weight of the solids divided by volume of the soil. That is understood, 100% clear for you. Now for a soil, I know the weight of the solids is constant for a soil. Okay, so suppose for a soil means this is a condition of soil, and I just compacted this to this much. Okay, so weight of the solids, here weight of the solids is same, but here volume is V1, here volume is V2, volume get reduced, but weight of the solids is same here. It's undergone compaction. This is a scenario. Now, so weight of the solids is constant. Here gamma D will be gamma D1. Here it is gamma D2. Now I am writing gamma D1. It is weight of the solids divided by V1. Here it is gamma D2. Weight of the solids divided by V2. Gamma D1 divided by gamma D2. I am taking the ratio. That is gamma D1 by gamma D2 is V2 by V1. This is one relation. Okay, gamma D1 by gamma D2 is V2 by V1. Now, I'm again going to say, suppose, yeah, one more equation is there, no? Gamma D is equal to G gamma W divided by 1 plus C. For a soil, G gamma W is constant. So I can write gamma D is inversely proportional to 1 plus E. Okay, so gamma D is nothing but weight of the solid divided by volume is proportional to 1 by 1 plus C. Weight of the solid is again constant. So volume is proportional to 1 plus E. Now I am going to arrive one more equation. V1 by V2 is equal to 1 plus E1 by 1 plus E2. 1 plus E1 by 1 plus E2. These two relations, you just keep it in mind. It will help you in some simple problem. See, the problem will be like, suppose they are saying like a soil is compacted to a soil of volume V1 is compacted to a volume of V2. The initial void ratio is even. Find the void ratio of second soil or after compaction. You can simply use this one. V1 by V2 is equal to 1 plus E1 by 1 plus E2. V1 known, V2 known, E1 known, E2 is unknown. Similarly, a soil of having gamma D1 value undergone compaction and the value reduced to gamma D2. The initial volume was V1 and what is the final volume? V2. You can simply use this equation. This is the idea. Okay, so you write these two equations, that is only needed. Gamma D1 by gamma D2 is equal to V2 by V1. V1 by V2 is equal to V1 plus E1 by 1 plus E2. Suppose this is actually very simple. V is equal to volume of solid plus volume of void. Okay, I'm taking VV as constant, volume of void common, not constant, common, volume of solid divided by, sorry, not. I'm taking VS common. So Vs is actually 1 plus volume of voids to volume of solids. Actually, volume of voids to volume of solids is E. So Vs into 1 plus E. This is actually V. Total volume, you can write Vs into 1 plus E. Vs is actually constant for a single soil. So I can simply write V is proportional to 1 plus E. From here also, you can directly write V is proportional to 1 plus C. So V1 by V2 is 1 plus E1 by 1 plus E2. Okay, that's it. Next, we are going to see. Yeah. The experiments. Once it is asked, which is the most accurate experiment in order to find the water content. Okay. So first I am going to share the experiments that to find the water content. Water content experiment. Okay. Suppose a soil is given to you, you need to consider the water, you need to find the water content of the soil. So water content of the soil, there are numerous experiments. So you just noted down the name of the experiments. One is oven drying method that you already did in your lab, oven drying method. This is the most accurate method. 2019 they asked, 2019 or 18 they asked, which is the most accurate method to find out the water content. Oven dry method. Pycnometer method is there. Pycnometer method. Third one is calcium carbide method. This is also important. Calcium carbide method. You just by heart these methods only. Okay, name only. They don't ask the details of this one and all. So fourth one is sand bath method. Sand bath method. Fifth one is radiation method. Radiation method. They will ask like this: which of the following is not used for water content determination? They will give pycnometer, calcium carbide, sand bath, and fifth one is maybe another wicket apparatus, something like that. Okay, so you have to know what are the experiments that is used to find out the water content. And torsion balance, sixth one is torsion balance method. Torsion balance method. Okay. Next, seventh one is actually alcohol method. Alcohol method. No need to study about the details of these experiments. You only need to know the oven drying method. That is actually very easy. That you know. Actually, you just take a soil of sample. Okay, and initially you take the weight W1. Then after oven drying 24-hour oven drying, you take the weight W2. Okay. Now the water content is actually weight of water. You can simply find out W1 minus W2. Okay, divided by weight of the water divided by weight of the solids. That is, weight of the solids is this much. After drying, you will only get the weight of the solid. That is W2. I'm going to modify the initial weight is W. The final dry weight is WD. So you can simply write this number W minus WD divided by WD. This is the water content determination method, oven drying method. That is only needed for you. And even pycnometer method is there. Pycnometer method is there, but that is a very big equation. Anyway, I'm going to write the equation, but it is not needed. W2 minus W1 divided by W3 minus W4 into G minus 1 divided by G minus 1. This is the equation. Now we have to check what are the W1, W2. See, pycnometer actually it's a jar, okay, having specific volume. So jar adil nama fill pannuvar, okay. That you know. Actually, in order to find out the specific gravity, you use this method, pycnometer. So initial weight you will take W1, empty weight. Then the same in the pycnometer, you are filling soil, that is wet soil. Okay. Now you are taking the weight is W2. Again the same pycnometer. Now wet soil is there. The remaining area you will fill with water. So that weight is you are taking W3. And finally, again pycnometer, you emptied the pycnometer. You fill the pycnometer with complete with water. You will get to W4. So W1 is the empty weight of the pycnometer. W2 is the empty weight plus the soil weight. W3 is the empty weight plus wet soil plus water. W4 is the empty weight plus water weight. Okay. G is the specific gravity. First you need to find out the specific gravity. Then you have to put in the equation. You will get the water content. So I'm not expecting a question from this area, but you can just memorize it. If it is asking, that is a good lottery for you. Okay. Now to find out the G value, I am going to use this one again, pycnometer method only. You can use G value. Okay, I am writing here. G is equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Try to mug up this equation because okay, W1, W2, W3, W4. Only thing is W2 is actually dry soil. Earlier it is wet soil in order to find out the water content, because water content all irukka soil thane nama edukuva, adinda water content thane edukanom. So adukkaga da water content oda adayithu wet soil nama fill pannittirukka enga in the second situation on the pycnometer plus wet soil. But in order to find out the G value, the soil should be dry. The dry weight plus the empty weight of the container, that is W2. Remaining same only. Here it is dry soil plus the water plus the container weight is W3. W4 is water only alone. Okay, water alone plus empty weight. So you have to put the equation, the values in this equation in order to find out the G value. This is specific gravity calculation. Okay, specific gravity calculation. Now these are the main, again, sorry. Okay, specific gravity calculation. That is a pycnometer method. Okay. Again, some more methods are there in order to find out the specific gravity. So water content methods that you wrote. Now, next one is specific gravity calculation, specific gravity determination. So adukkagulla experiments. First one is already we mentioned, that is pycnometer method. Second one is actually density bottle method. This is another density bottle method. Third one, it is shrinkage limit method. Shrinkage limit method. Okay, so these three are the methods for the find out the specific gravity. Now I am going to write one more experiment, unit weight determination. Okay, unit weight. So the experiment names are core cutter method. Just study the names only because they didn't ask any question from regarding this area. I mean unit weight, but specific gravity and water content names they are asked. Sand replacement method. Sand replace. These things are actually you did in your GT lab actually. Sand replacement method. Try to recollect that one, but no need to study the whole thing because the whole experiment it is actually not needed because they didn't ask. Again, I am saying we are studying based on the previous questions, the important areas. Okay, so these are the unit weight. At least try to remember these names: core cutter method, sand replacement method, and water displacement method. These are three methods are used to find out the unit weight. Again, it is in situ unit weight. That is cycle on the unit weight for the temp. And these are all lab experiments. Okay, these are all lab experiments. These are all site experiments. Okay, so this is it. Initial condition, that is the main properties, definitions, relations, and experiments that we concluded. Okay, so hope you understood. Now we are moving to index properties. That is very important that we will discuss today. So index properties. So I hope you wrote these things. Okay, just write first. So a quick recap. First we studied about the soil, the phase diagram. Okay, then we studied about the different volumetric conditions, volumetric definitions, void ratio, porosity, degree of saturation, air content, percentage air voids, and we studied about the weight-based relations, that is water content, unit weight, specific gravity. In unit weight of soil, unit weight of saturated soil, unit weight of dry soil, unit weight of submerged soil, unit weight of bulk soil. Okay, then unit weight of water, unit weight of solids. Then we studied specific gravity, the true specific gravity, gamma S by gamma W, apparent specific gravity, gamma D divided by gamma W for dry soil, gamma divided by gamma W for a bulk soil, gamma sat divided by gamma W for a saturated soil, gamma D divided by gamma W for a dry soil. Then we studied some relations, V1 by V2 is equal to 1 plus E1 by 1 plus E2, gamma D1 by gamma D2 is equal to V2 divided by V1, and we studied about the experiments that you are going to do to find out the water content, mainly pycnometer method and oven tray method. Oven tray method is the most accurate method that you need to study. Another method, radiation method, alcohol method, some sandbath method, that names you should remember. And the last one is specific gravity, that is again pycnometer method, density bottle method, shrinkage limit method, and in situ unit weight, core cutter method, sand replacement method, and finally water displacement method. These things we studied. Now we are going to see the index properties, that is very important. Okay, so index properties. Index properties. See, as I said earlier, actually these all things actually we studied for to find out the engineering properties. Why we need to focus on engineering properties? Because we are going to construct a building or a structure on the surface of the soil. The whole load coming from the structure or the construction have to be carried by the soil itself. So in order to carry the load by the soil should have some strength. Okay, the strength is imparted by some properties, that is what is called engineering properties. Okay, mainly that properties are we are mainly concentrated on because we use these in engineering applications. ஒரு சோயிலை பொறுத்த வரைக்கும் அந்த soil engineering property தான் நம்ம பிக் பண்ணணும் for solving the engineering problem. not our book problems, exact problems, real life problems. Okay. So what are that engineering properties? So engineering properties are main three properties are there. So engineering properties, first one is permeability, important one. Second one is compressibility. Okay. Third one is shear strength. These three properties, by knowing these three properties, we will get an idea about whether the soil going to be carry the load or not. Okay, whether the soil having sufficient bearing capacity. That is our term, bearing capacity. So if the soil has sufficient bearing capacity of the load, for the load, it will save. Otherwise, the settlement will occur or the crack will occur or the failure will occur. So in order to get an idea about the permeability, compressibility, shear strength, what we are doing is we will do some experiments, lab experiments, but that lab experiments are very, very time taking procedures. Okay. So in order to get a rough idea about the engineering properties, suppose the work that you are going to done in your site is a very less volume work. That means less important work, a single story building. So in that case, you don't need to do the experiments that give the value of permeability, compressibility, shear strength, but you need to know the rough idea about the permeability, compressibility, shear strength. In that condition, you can depend on the index property. That is the idea. So index properties are the indicator of the engineering properties. Indicator of engineering properties. That is the idea. This you should remember. Indicator of, what is indicator? Because the time taking procedures of permeability, compressibility, shear strength, that is very high time consuming and a very hectic procedure. But for a less important work, you don't need to focus on that kind of experiments. You only pick index properties. By knowing the index properties, you will get an idea about the engineering properties. That's all. Are you getting my point? You will get an idea about the engineering properties. For that one, we are using index properties. So what are the index properties? First one is grain size distribution. Grain size distribution. Second one is relative density. Relative density. Third one is consistency limit. These three terms are very important. You just note down. I am saying definitely they will ask question this year. See, last 3 years, if you are analyzing last 3 years, minimum 3 questions they are asked for from the relative density term. Minimum 3 questions. Last year itself, they asked, I think 2019, they are directly asked the equation for the relative density. So this is very important. Even though you are not studying entire syllabus of this geotech, at least you study index properties, you will definitely get 3 questions or 4 questions. Okay, so for the revision part, you just focus on these things, index properties. It's very important. Okay, one by one, we will see what is grain size distribution, what is relative density, what is consistency limit. These are very important. So what we need to know is grain size distribution. That is done by grain size analysis. See, what is our prime motto? Our prime motto is, or prime aim is to find the idea about your engineering properties. So by knowing the grain size analysis or grain size distribution, suppose you will get an idea, you are happy. Okay, you can proceed with your construction. Okay, so that is our agenda. So grain size distribution can be done in, or analysis can be done in 2 ways. One is sieve analysis, and second one is what is called by sedimentation analysis. See, the idea actually sedimentation analysis, again I am saying the question asked based on Stokes law, that you will see sieve analysis and sedimentation analysis. What is the major criteria to choose these two analysis? The criteria is actually the size of the particle. If size is greater than 75 micron, if size is greater than 75 micron is 10 raised to minus 3 mm. Okay, 10 raised to minus 3 mm micron. You can choose sieve analysis if size is less than 75 micron. Okay, so it is, if size is less than, it is fine grained soil. We will see the classification, okay, soil classification in the next chapter, fine grained soil. So next is, if the size is greater than 75 micron, it is coarse grained soil, coarse grained soil. Okay, fine. This is the idea. So this should be noted, size. Okay, this is very important when you are going to choose sieve analysis and when you are going to choose, when you will choose sedimentation analysis. If size is greater than 75 micron, you will choose sieve analysis. If size is less than 75 micron, you will choose sedimentation analysis. So sieve analysis, that you know, as the name indicates, the sieve, you are taking some sieves, okay, in order to sieving is the process of filtering, you know. Different pans are taken with a different mesh size, that you know, in your laboratory you just did these things, okay. So each pan having meshes, filters, right, having different sizes, okay. Some having 4.75 mm mesh size, okay, 2.36 mm mesh size, 1.18 mm mesh size, and finally 75 micron, that means 0.0575 mm mesh size. So different sizes of mesh are taken, and you are just pouring the soil, a known quantity of soil W, you are just pouring the soil in this first mesh, and you allow this all setup in a vibrator to vibrate. Then the sieve automatically happen, and the particles which the sizes are lesser than the mesh size, it will move to next pan, and it will move to next pan, and thus you can see different sizes of particles are trapped in different sizes of mesh. Okay, so in the sieve analysis, I'm going to say one term, I mean one idea, that is, if you are, this is a mesh, oh sorry, this is a pan, you are suppose this is a 4.75 mm mesh size pan, you take some amount of soil here. So after sieving, some amount of soil will retain here and some will pass through the 4.75. So size greater than 4.75 mm retain here, size less than 4.75 mm will pass here. Okay, the retained portion will be called coarse fraction. Coarse fraction. The past part is called fine fraction. Okay, that is also important. So coarse fraction and fine fraction. Okay, now our idea is, okay, anyway we did our sieving through this one. So in each pan, whatever amount of soil is retaining, that is collected and weighed. Suppose in the first pan W1 weight, in the second pan W2, in the third pan W3, in the fourth pan W4 weight, fifth W5, likewise. Okay, then you are creating a graph. That is very important, a log graph. Okay, in the x-axis you are taking the log scale, x-axis you are taking the size of the particle, y-axis you are taking the percentage finer. Percentage finer means, suppose before creating this graph you are making a table. First sieve size, okay, sieve size, suppose 4.75 mm first, then 2.36, 1.18 mm. These are the standard mesh sizes. So first you are creating a sieve. Now percentage retained, that you find. Percentage retained, how you find percentage retained? You know W1 is the retained in the 4.75. The total weight is W. Total weight is W. You will find W1 divided by W into 100. You can call it as P1. Here W2 divided by W into 100. You can call it as P2. Okay, that is percentage retained. Now cumulative percentage you are finding. Cumulative percentage means you are just adding. Okay, so Q1 is here, it is P1, same. Q2 you are just adding these two, P1 plus P2. That means cumulative means 2.36 up to 2.36. This much amount of percentage of soil is retained. Okay. Now cumulative, after that cumulative, you are finding percentage finer. That is our y-axis. Percentage finer. That means P1 is actually 4.7 in the 4.75 mm. P1 amount of soil, percentage soil is retained. And 100 minus, out of 100 percentage, 100 minus P1 is passed. Okay, it passed through 4.75. So 4.75 mm size of sieve-ne പൊറുത്തവരേക്കും 100 minus P1 amount of soil is finer than 4.75 mm. Similarly, 2.36 mm size of sieve, if you are considering 100 minus P1 is Q1 same here only, so 100 minus Q2. Okay, so 2.36 mm size, if you are considering that one, 100 minus of Q2, that much amount of fine soil is finer than 2.36. Similarly, 1.18. So you will get a different values. You can create a graph by percentage finer versus size. So you'll get different shape of graph. That is our important area. So this graph is called grain size distribution curve. Grain size distribution curve. It's very important. Grain size distribution curve. What is our main agenda in order to find out the index property, that is grain size distribution? So for that one, we did first one is sieve analysis for size greater than 75 micron. So I got a grain size distribution curve by taking y-axis as percentage finer and size, particle size in the x-axis in the log scale. So I will get a different size or different shape of soil, different shape of graph for different soil. See, actually soil means if you are collecting a soil, you cannot see a same size of soil particles. Different sizes of soil particles are packed in different way. Okay, different sizes of particles you can see. That is our idea. We need 1 minute. Whatever. Okay, we need different sizes of particle in different composition, I mean different fraction in order to get a good soil. That means, see, suppose these are the soil particles of size, say 4.75 mm. Okay, so you see the gap between soil particles. So in that gap, size lesser than initial soil particle should be there. Again, there will be gap between the small size. So the size less than that small size should be filled with in that void spaces. So thus a soil should be in a good compact form. Okay, in a good graded form. These are called grading, because maximum contact of particles should be there to each other. Maximum contact of particle should be there. 1 minute. Yeah, maximum contact will be there in order to get a good shear strength. Okay, but good shear strength or shear strength is depending on the contact of the particles. That is very important. So in order to get a good contact, the soil should be graded in such a way that a good amount of different sizes particles should be distributed in such a manner that all particles should be in a good contact. That is the idea. So in that case, if you draw the grain size distribution curve, you will get a graph like this. Okay, that is called well-graded soil. Well-graded soil. Well-graded soil. For our scenario, if you are going to consider a soil for a good shear strength, you should be resulted in a well-graded soil. Okay, the result should be a well-graded soil. That is our prime agenda. We need a well-graded soil. That is the idea. Okay, now suppose some particles are mixed. Okay, see, a well-graded soil means different sizes of particles are proportionally filled in a different way. Okay, it means in a good way. Okay, so that means it having all different sizes of particles. That well graded soil having all different sizes of particles in a good proportion. That is the idea. Now, some soil, if you draw the size distribution curve, you can see some soil will be like this. Some soil will be like this. This is actually called a gap graded soil. Gap graded soil. That means gap graded soil means certain sizes are missing there. Ayo, okay, gap graded. That will, I will draw one more. This is gap graded. Gap graded. Certain sizes of particles are missing there. Gap graded soil. Okay, now this is gap graded. Another one of shape is something you will get like this. This is a uniformly graded soil. So these three different types of soil distribution curve you can expect, but our aim is to get a soil like a well graded soil, because all the particles are of different sizes in a good proportion is available in the well graded soil. In a gap graded soil, some sizes of particles are missing. A uniformly graded soil, actually the same sizes of particles are available. Okay, in a uniformly graded soil, same size of particle are available. Okay, gap graded some sizes are missing. Well graded all size particles are available in good proportion. So our aim is to get a well graded soil. Now uniformly graded and gap graded, collectively we can call it is a poorly graded soil. Poorly graded soil. Okay, uniformly and gap graded, those two are called poorly graded. Okay, don't confuse with it. Poorly graded means gap graded and uniformly graded, collectively we call it poorly graded, and well graded is a best soil, that I can say. Well graded soil is the best soil for our construction. Okay, so any doubt you just ask. I will okay, Vinod, Vinida, Kamala. Okay, so I will give time for you. Is there any doubt? Because a lot of questions are asking based on these areas, so you should thoroughly understand the idea. Okay, if there is any doubt, any clarity, you need any clarity, you just ask.
Sir, is there any question in this table, sir? Sieve analysis table.
Sorry. Any question?
Any question asking in sieve analysis table?
Sieve analysis table, no. They are not going to ask any questions regarding sieve analysis table, but they are asked about the well-graded soil and gap-graded soil, and even we are going to define two more parameters here. So that kind of question, coefficient of uniformity and coefficient of curvature, that we are going to discuss, that they ask. But why I just given an idea about the axis, I mean percentage of fine art, how they are calculated, you just get an idea. Okay, you just go through the idea how they created the percentage of fine art. If suppose if they asked a question regarding they are giving the values of sieve and percentage return, you can simply find out the percentage fine art. That's why I just given the idea, but no need to deeply focus on this area, but just keep it in mind. Okay, percentage return they calculated, cumulative they calculated, 100 minus cumulative, you will get the percentage final. Okay, but I think they didn't ask any question based on the tabular form based on for this grain size distribution, but they asked some parameters that we will going to discuss based on the graph. Okay, so you get the point of well-graded soil, gap-graded and uniformly graded. You are getting an idea, I hope. Okay, next I am going to discuss one more important term. So that is what is we are getting from the distribution curve itself. Okay, so we need to focus on that one. Okay. So distribution curve that you got idea. So from where we get the distribution curve? By doing the sieve analysis. For what kind of soil we are doing the sieve analysis? For the size greater than 75 micron, mainly coarse grained soil. So now by analyzing the sieve analysis graph, that means your grain size distribution graph, I'm going to find some parameters. Okay. Yeah. Just see. Suppose for a well-graded soil, for a well-graded soil, I'm getting a graph like this, and S-shaped, almost S-shaped. Okay. Suppose now I am going to find, okay, this is particle size, and in the y-axis, percentage finer. Now you will get more idea about what is percentage finer. Suppose I am going to mark this size. Suppose this size is 0.001 mm. Okay, and this is 10 percentage. Percentage finer anyway you will get in the 10 percentage in 10 suppose this is 10 percentage. So how we are going to express this one is D10 is equal to 0.0101 mm. This is the idea. D10 is equal to 0.001 mm. Okay, which means from this graph I am just taking D10 is equal to 0.001 mm. This is the result I got from this graph as per this marking. Okay, so how you are going to define this D10 is equal to 0.001 mm means 10 percentage of the particle, 10 percentage of the particle in the soil. Okay, 10 percentage of the particle are finer than 0.001 mm size. That is the idea. Okay, you just look to the statement. 10 percentage of the particle are finer than the 0.001 mm size. That is a D10 is equal to 0.001 mm. Suppose you are getting a soil, you just you did the sieve analysis. From that, out of the total weight of the soil, now 10 percentage of the soil are size of 0.001 mm finer. Okay, that means 10 percentage of the particles are finer than 0.001 mm. Suppose you are taking D30. Okay, 30 percentage corresponding value is 0.1 mm. That means 30 percentage you will get D30 as 0.1 mm. Okay, so 30 percentage of the particle are finer than 0.1 mm size. That is the idea. Now I am going to take D60. Okay, 60 percentage. So D60, suppose the value is 0.1 mm. Okay, 1 mm. So that means 60 percentage of the particle are finer than 1 mm size. This is the idea that you are getting from the distribution curve. Okay, now I am going to define using this D10, D30, D60. D10, D30, D60 are some important sizes. So D10 is actually called effective size. D10 is actually called effective size of the soil. Okay, so that you should remember D10 effective size of the soil. D60 and D30 are randomly taken some values, sizes in order to define some parameters that we are going to define. So D10 is the effective size. Okay, D10 is the effective size. D indicates actually diameter. Size means diameter. Okay, diameter. This 0.1 mm is actually it is diameter. Size means diameter. So diameter of the particle which is finer than 0.001 mm. Okay, that is actually what is called D10. It is an effective size. Now I am going to define the important parameter, that is what is called coefficient of uniformity. Coefficient of uniformity. That is CU. Very important. Last time they asked CU. CU is equal to the ratio of D60 divided by D10. Please try to mug up this equation. This is very important. Cu is equal to D60 divided by D10. Please try to mug up. And second one is coefficient of curvature. Coefficient of curvature. It is Cc. Cc is equal to D30 square divided by D60 into D10. Again, I am saying, please try to mug up this equation. Very important. Cu and Cc. Look at this. Cu is equal to D60 divided by D10. Coefficient of uniformity. Okay, coefficient of curvature, D30 square divided by D60 into D10. These are two parameters, two parameters which is going to be carry an important role in the soil classification that we will see. Okay, for the time being, I am just giving an idea about the coefficient of uniformity. If Cu value is greater than 4, it is a well-graded soil gravel. A well-graded gravel. Anyway, this we will see in the next chapter. Okay, if Cu is greater than 6, that is a well-graded sand. So if you know the Cu values, you will get an idea about if it is well-graded or well-graded gravel or well-graded sand. That is the idea. Okay. Now Cc value. Okay. Suppose this is for a well-graded soil, right? This graph is for a well-graded soil. I can simply write for a well-graded soil, D60 is greater than D30 greater than D10, right? Because you can see that one. For a well-graded soil, D60 greater than D30 greater than D10. That is the idea for a well-graded soil. But for a uniformly graded soil, see, I'm drawing this with a different color. This is a uniformly graded soil. You can see this is a graph of a uniformly graded soil. If you are going to plot D10, D30, D60, almost you will get the same value, right? It will in the range here. So I can say for a uniformly graded soil, D60 is almost approximately equal to D30, almost equal to D10. This is a different scenario for a well-graded and for a uniformly graded. Okay, so these are the things you have to remember. Cu, what is Cu? That is coefficient of uniformity. And if Cu, again I am getting a point, if Cu is less than 2, it is a uniformly graded soil. Uniformly graded soil. Okay. Yeah. So coefficient of curvature is D30 square divided by D60 into D10. For a well-graded soil, I'm going to write for a well-graded soil, you can see Cc lies between 1 and 3. See, well-graded soil, Cc lies between 1 and 3. Okay, this is the idea, basic idea. These are the points you have to remember. These 3 points, Cu values, range and all. Okay. Now, in order to, I will give you a trick that you can remember. That is coefficient of uniformity. See, coefficient of uniformity. Sometimes the students might have confusion with coefficient of curvature and coefficient of uniformity. See, coefficient of uniformity, that means uniformity in the numerator and the denominator. There will be only one term in numerator and only one term in the denominator, D60, D10. Anyway, D60, D10, that you have to mark out. Okay. Coefficient of curvature. The curvature is more than second degree, third degree equation. Okay. So you can see curvature means there is a power. Okay, so D30 square divided by D60 to D10. That is not uniform. Numerator to one value, denominator 2 value. So that should be related to curvature. Okay, and it should be having second degree. So second degree is always curve. Now, coefficient of uniformity is numerator one time, denominator one the other time. So uniformity is there. So D60 by D10. That is the idea of size. Okay, different parameters. Okay, so effective size, that you know, D10 is an effective size. Okay, effective size of the soil. D60, D30 are another random sizes in order to define this uniformity coefficient and curvature coefficient. So these are the idea. Okay, so now we studied the grain size distribution. Okay, grain size distribution. The second thing is where we started. Yeah, see, sieve analysis. By doing sieve analysis, we completed grain size distribution. The second is actually you can see the grain size analysis by sedimentation also. Where you are going to use sedimentation, you are going to use sedimentation analysis in where the size is less than 75 micron, that is fine grained soil. So now I am going to check the sedimentation analysis. But in sedimentation analysis, you only need to know one law, that is only needed. But sedimentation analysis, there are two approaches like sieve analysis. There is one is hydrometer method. So no need to study the procedures of hydrometer method and all for the these kind of exams. Second one is pipette method. These are the two methods under which sedimentation analysis. But what you need to concentrate is sedimentation analysis is based on Stokes law. Stokes law. Very, very important. Stokes law. Focus on that one. Stokes law. So Stokes law or Stokes principle, it is defined the terminal velocity. You might have heard about the terminal velocity word. Terminal velocity. Okay. Or settling velocity. This term you might have heard. Settling velocity. Now we are going to define. Suppose a particle is traveling through a medium. Okay. If it is traveling to a medium. So this is moving downward. Anyway, gravity is attracting downward. Gravitational force is attracting downward. Suppose this is a fluid. Anyway, the buoyant force is acting upward. A scenario is occurring. Initially, it is accelerating like anything. Acceleration is occurring. At a point where these two forces are balanced, that is, the downward forces and upward forces are getting balanced, then a scenario is created where this particle will travel at a constant velocity. That velocity is called terminal velocity. Okay, when a particle is moving in a fluid medium, initially it is accelerates, and after a particular point, the forces get balanced. Which are the forces? Downward forces, that is the gravity forces, and the upward forces, buoyant forces, get balanced, and a scenario is taken where the velocity become constant. Then after that, it will move with that velocity. That constant velocity is called terminal velocity or settling velocity. We have to only focus on what is terminal velocity or settling velocity. How we can find out the terminal velocity or settling velocity? You can simply find out using equation g by 18 into capital G minus 1 into d square divided by nu. Okay, this is the equation. You just you need to mark up because this equation is again coming in environmental also. Okay, so in environmental part also we are going to study this equation. Anyway, see, this equation is actually g by 18. Okay, g by 18. Actually, this g is specific gravity. Okay, that you know, specific gravity. Sometimes they will use s also, s minus 1 also. Anyway, I am using g minus 1 into d square. D is the diameter of the particle. Okay, and divided by nu. Nu is the kinematic viscosity. Nu is the kinematic viscosity. Kinematic viscosity. In fluid, you will study kinematic viscosity, that is mu by rho. Mu is the dynamic viscosity. Okay, nu is equal to mu by rho. So this is the equation, Stokes law equation. Just by heart this equation. Anyway, it will use in three subjects: GT, environmental, and fluid mechanics. Okay, nu is equal to kinematic viscosity is equal to, that is mu by rho. This is the basic equation for Stokes law. Stokes law defines the terminal velocity or settling velocity. And Stokes law, yeah, someone, any doubt?
Yes, sir.
Tell me, man.
Sir, what about the small g, sir? Acceleration, gravity, sir?
Yeah, G is always gravity. G is
Okay, sir.
acceleration due to gravity, 9.81. Acceleration due to gravity. Okay. Now, last, I think 2019, they asked, the Stokes law is valid for the particle size. Here I am going to write that answer. The Stokes law is valid for particle sizes between 0.2 mm and 0.2 micron. 0.2 micron. 0.2 micron means 0.2 into 10 raised to minus 3, 0.002 mm. Okay. 0.2 mm and 0.002 mm. This question is asked in the last 2 years back, 2019, I think. Very important. Okay, so Stokes law gives the terminal velocity of a sphere. Okay. And it is valid only for the diameter of 0.2 mm to 0.2 micron. Better to study in 0.2 mm to 0.2 micron. Then you can convert into mm. And this is only for laminar flow. This is only for laminar flow. Stokes law is valid for laminar flow. That is again important thing. Laminar flow, that you know. Laminar flow is an ordered flow. Okay. Turbulent flow is an random flow. Okay. There is no order there. So that is regarding the Stokes law. This is very important. Please study this equation. You can use in 3 different subjects. Okay. Now I hope you wrote these things. Next, last topic, that is relative density. Again, I am saying our second index property is relative density. This is asked many times. So make the star above it. Please not like this, because it's very important. So how you are going to define the relative density term? Actually, relative density, otherwise you can call it as density index. Density index. Okay, so it is ID, it is denoted by ID. So first I am going to define that ID value, then we will explain. So ID is actually E max minus E divided by E max minus E minimum. This is the idea of ID into 100. So what it indicates? See, relative density, you are going to compare the densities with something. That is where the term relative comes, right? So relative means we are going to compare. You are going to compare. So where you are going to compare? See, E max minus E. See, this E is natural void ratio of a soil. Natural void ratio. Natural. Yeah, tell me, man. Vinod.
Excuse me, sir.
Yeah. Tell me.
Sir, could you open the previous slide, sir?
Yeah, okay. Yeah. 1 minute.
Yes, sir.
Yes, ma'am.
Sir, Stokes law valid for between 0.2 mm to 0.2 micron, sir.
Yeah, micron.
So below that you written in mm, sir, in both dimensions.
Yeah, actually I just converted this micron into mm. Micron is 0.2 into 10 raised to minus 3.
Then it will come 0.00002 will come now, sir.
0.1 10 raised to minus 3.
Minus 3 now, sir.
10 raised to minus 3. Yeah, yes. 0.2. Yeah. One more 0 is coming. Yes. Yeah, thank you.
Fine, sir.
Yeah. Literally 2 into 10 raised to minus 4 mm. Okay. So 1, 2, 3, 4. Yeah, yes. I just missed that 0. Okay. Okay. Back to our relative density. So Emax minus E divided by Emax minus E minimum. What is E? E value is natural void ratio of the soil. Now the relative term comes. So I am going to compare with something. So something is what? That I am going to see. Emax means is the maximum void ratio. That is a maximum void ratio in the loosest state. See, now I am going to compare my natural soil. Suppose I just collected a soil from the ground. Its natural void ratio is E. Okay. Now I just make the soil in a loosest stage. Okay, it's a loosest stage. I just try to make this soil in a loosest stage, and I found out the E value. That is a E max value. So E max is a maximum void ratio in the loosest state. E minimum means that is a minimum void ratio. Minimum void ratio in the densest state. In the densest state. That is the idea. What I am going to make, this is the soil condition. I just compacted and I just make it in the maximum densest state, and I'll get the E minimum value, because in the maximum densest state void ratio is minimum, because the void spaces is minimum. So that is idea. So maximum E and minimum E, that is, I just compare my natural soil void ratio with the soil in the loosest state and soil in the densest state. That is what is called ID relative density or density index. And the equation is, see, I am just comparing E max minus E divided by E max minus E minimum into 100%. This is the idea. Okay, again, the range, if you are going to take, it's a range. Sometimes, suppose if natural state, if suppose I just collected the soil from the ground and it's found to be in the loosest state, that means my E become E maximum. Okay, if your natural state of soil is in the loosest state, then your E become E maximum. Now you put that E here, so E become E maximum. So E max minus E max, so ID becomes 0. Okay, so when E become E max, ID is 0. Now when I am going to collect the natural soil, then I found to be the soil is in the densest state, so my natural E become E minimum. Then I just put that E value in the E minimum. So E max minus E minimum divided by E max minus E minimum into 100, that is 100%. So ID is 100%. So my range of ID is 0 less than or equal to 100%. Now just come out with the values. Let's take the ID is 0. ID 0 means E is in the E max. E is in the E max. That means your soil state in the maximum loosest state. Maximum loosest state. So that means ID, that is your relative density is very, 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 very loose. Okay, very loose. Density is very loose. Suppose E become E minimum, your soil is in the densest state. That means the density is in the densest, very, very, very dense state. When ID is 100%, that means pakka density, very dense, rigid soil. When ID is equal to 0, that is the pakka loosest, very loosest state. So in between 0 and 100, the soil state varies. So that is a range. So I will share that values. If ID is less than 15, I'm not considering 0. 0 is not going to be exist. So ID value is less than 15. Then the condition is very loose. Soil is very loose. If ID is between 15 and 35, the soil is stated to be loose. If ID is between 35 and 65, soil is said to be medium dense. If ID is between 65 and 85, the soil is said to be dense. If the ID is greater than 85, the soil is said to be very dense. This is the idea. So please take these values to you, because it will help you. Sometimes they will ask, they will directly give the Emax, Emax, E minimum values, and they will ask what is the condition of the soil. So first you find out the ID value, then you find where this ID limit values lies. If it is 35 and 65, if it is between 35 and 65, you can say it is a medium dense soil. In the option, they will see very loose, medium dense, and dense. That kind of questions they can ask. So this is very important. Again, I am saying, please study this one. Okay. definitely you will get a mark, because last 3 years they are consistently they are asking relative density questions. Even last time I just think they are asked question, I mean problem. Okay, they are asked problem. So anyway, that we will discuss the previous whatever questions they are asked. We will discuss in classes, coming classes. This is just an initial class. That's why I am not going to giving questions and all. So next class onwards, I will share the questions and we will discuss that one. Okay. So this is regarding the relative density, and the last term is actually consistency limits. Anyway, I'm going to stop here. Then we will continue. So can you 1 minute? So what about afternoon? Actually, I am little bit busy with afternoon. So can we continue with these topics in tomorrow? Is that okay for you? The remaining topics tomorrow?
Is there a session in today, sir?
No. Actually, I had a plan to afternoon, but I have to attend some other kind of things. So I think I cannot take the classes afternoon. Okay. So tomorrow I will take afternoon classes. Complete whole day classes will be there. But today I couldn't. So sorry for that one. And we will stop here. So if any doubt, you just ask me. If any doubt is there, you
Yes,
just
sir. I have doubts, sir.
yeah, tell me. Hey Kamal, and what about just hold Vinod, Kamala, Vinita, please ask any doubt. Anyway, I am going to ask the questions tomorrow. You just come and prepare very well. Whatever things we studied till now, you just go through that one. And if any doubt arises, you just please come with that doubt tomorrow. Anyway, I will ask some point tomorrow in order to recollect from the today's study. Okay. Okay, Vinod, tell me.
1 minute, sir. Sir, interrelated relationship எடுத்தீங்களா சார்? வாய்ட் ரேஷியோ போரோசிட்டி அதெல்லாம் எடுத்தீங்களா சார்? அதுல நம்ம வாய்ட் ரேஷியோ போரோசிட்டி ரிலேஷன்ஷிப் பேஸ் பண்ணி ஒன்று இருக்குல்ல சார். E equal to n divided by 1 plus n, then n equal to E divided by 1 minus E.
Oh, that I think that
Yes,
that one, right? Yeah, one equation is there. Yeah. Only one equation you need to study. That is
Yes,
equal to only one equation. Then you can reverse it one. N is equal to E divided by 1 plus E. Sorry, I forgot to tell that one. Even that is not actually. It is easier for to derive that equation and all. It is simply, I will show you. Wait. Yeah. Right. Okay. So there is a relation between E and N. Okay, that is void ratio and porosity. So what I'm going to do is, porosity is actually, you don't need to mug up these things because you can easily derive from the equation, I mean base equation, that is volume of voids to total volume. N is volume of voids to total volume, that you know. So volume of voids means nothing but, that is I am going to volume of voids divided by total volume means that is volume of solids plus volume of voids. Okay, so this is volume of voids divided by volume of solids plus volume of voids. Now, I'm just taking 1 by n. Okay, so you will get to Vs plus Vv divided by Vv, or you can divide it with Vs. Okay, so Vs you can divide. So volume of void divided by volume of solids. That means Vs you are taking common. So volume of void divided by volume of solids, that you will get E. Okay, divided by volume of solids you are already taken common. See, that means Vv divided by Vs, you are just taking Vs plus Vv divided by Vs. Okay, you are just dividing with Vs, or you are just taking Vs outside. So Vv by Vs, that is E. So Vs by Vs, that is 1 plus Vv by Vs, again that is E. So N is equal to E divided by 1 plus E. Okay, so that is the basic equation. N is equal to E divided by 1 plus E, or E is equal to N divided by 1 minus N. Either one of the equation you have to mug up, or you can easily derive from the basic equation. Okay, so it will be better N is equal to E by 1 plus E. It will be better if it is okay for you, you can mug up this one, or E is equal to N by 1 minus. Sometimes they will give N value. From the N value you can find out the E value. That's the idea. Thank you, Vinod, to remembering this one, because I just forgot to add that one. Okay.
Yes, sir. No. So one more thing, sir. Last one, sir.
Okay. Remaining,
So-
I think I covered everything regarding the relations, and if anything missed, yeah, okay. Anyway, one more thing actually I just missed, so I will discuss that. That loosest packing and the densest packing E value. Okay, that I will just share you. Anyway, only 2 minutes it will take. See, okay. See, the thing is, actually, I already discussed with Vinod. See, if I am going to consider the soil particle shape as what, the spherical shape, suppose if I am going to arrange the spherical shape like this, okay, this is one above the other, one above the other, first kind of arrangement, one above the other. In the second phase of, I mean, second kind of arrangement, I'm just arranging the things like this. This is a diagonal arrangement. The gap between two particles or void spaces, I just put the other particles in that gap. Okay, this is diagonal arrangement. Okay, so this is the two different types of arrangements. Okay, but the scenario is, okay, this is the loosest packing, I can say. This is the loosest packing. And this is the densest packing. Densest packing. Okay. Otherwise, you can call it as diagonal packing. You can see diagonally, you can draw some diagonals, diagonal packing. Fine. So this is something called a cubical array. You can see in a cubical way. Okay. Cubical array. Okay. So this is a spherical space. Okay. Spherical shape. So if you are going to consider the spaces in between these shapes, and you are going to find out the E value, you will get a value of E max, that is a maximum value of 0.91. Okay, that's mathematically it's proven, because you can see the shape. You have to find out the shape volume, and you have to find out the total, I mean, volume of the spheres. And if you divide it with, you will get a 0.91 value. And if you are going to find out the the value of E here, you will get the E minimum. So that is a value. Yeah, okay. So this is the cubical array or loosest pack. You will get the maximum. In the loosest scenario, you will get the maximum void ratio, that is 0.91. And this is the compact array or densest packing. You will get a E minimum. Okay, E minimum, that is 0.35 value. Plus, please remember these values. In many exams, they asked E max and E minimum if they are going to arrange this in this way. Okay, that's the idea. So that is a minimum value and maximum value. This is not for the real soils. Okay, this is for only we are considering it as a spherical shape, then only we will get this kind of values. Okay. Okay, for that I think almost all things are covered. Why we are taking this much time? Because I just focused on most of the areas where the questions, previous year questions asked. So in upcoming topics, actually, even index properties also, they are asked a lot of questions, but for coming for the permeability, effective stress, they are not asking majority of questions. So there we will move in a fast way. Okay, then questions are coming from the consolidation, compaction, and shear strength. So there we have to focus many areas, and even foundation also. So by I think I can complete this with 20 or 25 hours. Okay, that is needed actually, because a lot of subjects are going to be covered in this 2 month span. So you need to collectively study all the subjects according to the previous year status and all, strategy and all. Okay, so for the time being, I'm just going to wind up the classes today. So anyway, thank you for attending the classes. So we will see tomorrow. Tomorrow we will continue with this index properties. The major portion is coming, that is consistency index. So, and the next thing is actually soil classification. Again, that is very important. They are asking questions from the soil classification. It's a very small chapter and very easy chapter also. So if there are any suggestions regarding the classes or the nature that I mean the way of teaching, if any suggestion, you can directly speak to me, no issue. Okay, and even the doubts and anything that you can ask in Tamil. I know Tamil actually, but the fluency is not that much good. That's why I'm very much using the English. I hope you are easy, you are understood with English and all. And anyway, in the future classes, I will handle with the. I will mix with the Tamil also. Okay. So,
Sir,
yeah, tell me. Yeah,
sir, excuse me. Sir, what will be the tomorrow's topic, sir?
I will continue with the index properties, the remaining consistency limit, and the next one is we will continue with the soil classification and
Okay, sir.
permeability, effective stress, and seepage analysis.
Okay, sir. Today's continuation. Okay, sir.
Yeah, today's continuation only.
Okay, sir. Okay, sir. Thank you, sir.